pertama. Nanti sesi kedua kan ada yang dari Pak Firman sama tim. Boleh? 15, 10. Ya, jelas. Selamat siang semuanya. Assalamualaikum warahmatullahi wabarakatuh. Salam, Om Swastiastu, Namo Buddhaya, salam kebajikan untuk kita semua. Kami dari panitia mengucapkan terima kasih kepada yang terhormat Bapak Firdaus Rosehan Roni selaku Direktur UI Advisory, kepada yang terhormat Bapak Profesor Dr. Ari Yanuar MSI APT selaku Dekan Fakultas Farmasi UI, kepada yang terhormat Bapak Profesor Al-Hadi Bustamam MKom PhD selaku Guru Besar FMIPA UI, kepada yang terhormat Bapak Muhammad Hilman yang saat ini masih belum hadir selaku dosen dari Fasilkom UI, dan kepada Oi Joshua, Brian Chandra, New Steven selaku tim Project Ristek UI, dan juga kepada seluruh hadirin yang namanya tidak dapat kami sebutkan satu persatu untuk menyediakan waktunya hadir di acara seminar internasional ini dengan tajuk Latest Developments in Data Science, Supercomputing for AI, Case in Portofolio, Generative AI, Ethical Considerations, Exploring the Global and Local Experience. And also would like to extend the warmest welcome to our esteemed guests in this seminar, Alexander Krainov, who currently serves as the Director of AI Development at Yandex, and Alexander Popovsky, who currently serves as the Vice President of Strategy at Yandex. Izinkan saya, Erlan Rahmat Ramadan, selaku pemandu acara seminar internasional ini, untuk hadirin, untuk berdiri di tempat masing-masing, untuk menyanyikan lagu kebangsaan tanah air kita, Indonesia Raya. Terima kasih. Sebelum hadirin kembali duduk, saya mohon hadirin tetap berdiri di tempat masing-masing untuk sesi foto sebagai kenangan-kenangan dari acara ini. Ya, ya. Uh, uh, ya. Peserta dapat maju ke depan untuk mengambil foto. Terima kasih. Para hadirin dan para pembicara bisa kembali ke tempat duduk masing-masing. Ya, mari kita mulai kembali acara ini dengan mendengarkan sambutan dari Pak Roni. Kepada Pak Roni kami persilakan.
Tes, tes. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, salam kebajikan. Uh, Special greeting to our honored guest from Russia, Pak Mr. Dudi with team, and thanks for your assistance to our alma mater here with us, our commission. Okay, I would like to say, Priyat Minye Zafutroni Oci Priyatna. I hope there are no mistake in spelling in Russia. Okay. Welcome to our honored guest from the Faculty of Pharmacy, Dean Prof. Ari Yanuar, Prof. Al-Hadi from the Data Science Mathematics University of Indonesia, and from Russia, Mr. Alexander Krainov and Mr. Alexander Popovsky and Mr. Hilman from Fasilkom UI. Okay, I think for the 74 years relationship between Russia and Indonesia, established relation in diplomacy since 1950, 74. It's long enough. Indonesia, country with 277 million people. When with our partner Russia, about 144 million people. Yeah, data from the Google's 2022. And let's give us the applause for the Russia friends, Mr. Popovsky and Krainov. Okay. And if we say about in Russia, in our top of mind will be about the Putin, Ura. Also about the GLONASS satellite, also Marsha Little Girl Bear and her beer. Also the from James Bond, From Russia with Love. Okay, right. We had to move to today. We embark in recent collaboration in the field of data science and AI, particularly focusing on sharing insight from side of pharmacy, Prof. Arianwar, and about the Asian artificial intelligence in the health, about the retinal fundus, yeah, Prof. Al Hadi, and also about subject related. And we also have a plan to make a collaboration in artificial intelligence regarding the data science about the transportation with Yandex. We have the national public transport in our city, Jakarta. It consists of the user traffic about 1.4 million a day traffic. Also, we have a plan about the mental health. Mental health is also interesting subject in Indonesia because about the 40 million people need approach to mental health solution about the stressing people in here. It's a big business to growing big chunk about that. And we are delighted our process building strategic partnership with Russia company in the field of search engine like AI beside the Google. We welcome the establishment of representative office from UI to Yandex Russia. This collaboration will serve as leadership institution for UI advisory and Directorate of Cooperation of UI, DKSUI, together with Faculty of Mathematics and Natural Science and Department Mathematics especially, together also with the Faculty of Pharmacy and Faculty of Computer Science. We also the young talent from here also champion in the artificial intelligence event. Mr. Oi and friends, yeah, okay. To save the time and proceed with the agenda, I will offer the proceeding to our MC moderator, Mr. Erlan. Thank you.
Let's give an applause to Prophet Dr. Paroni. So without further ado, let's welcome Alexander Popovsky on his delivery on his presentation on generative AI ethics. So allow me to explain a little bit about Alexander Popovsky experience. So after graduated from Viatka State University, I'm sorry if I pronounce it wrong, from systems engineering, he worked at Kirov Electrosfast as the head of data transmission network. And then in 2001, he moved to mobile network operator MTS, where he worked his way up from the director of the Kirov branch to VP of operations. And he was deeply involved at the time in building MTS first operator retail network and launched the company's 3G and 4G mobile networks. So in 2013, Beeline hired him as the executive vice president for mass market development. And under his leadership, the company was the first to introduce plans bundling mobile and home internet, and was also the first to release a family plan. And he managed to integrate of Euroset, the Russia's largest mobile phone retailer at the time, into Beeline's retail network as well. So Alexander Popovsky joined Yandex in 2021 and is responsible for all strategic projects for the search and ad tech business group. And his current responsibility is to build search presence abroad, including in Kazakhstan. So, for Alexander Popovsky, the time is yours.
Thank you. Maybe I'm going to be really brief today, but Your Excellencies, ladies and gentlemen, thank you for having us here. It is a big honor for Yandex to present here today in Indonesian biggest, largest, and the most esteemed university. Yandex has a long history participating in different events with the universities all over the world, in Russia and Indonesia too. And we will be happy to share our experience in artificial intelligence and machine learning today also with you. Just to start with, maybe a few words about Yandex. If you switch maybe to the next slide. Oh, maybe the first one about Yandex was a nice diagram. Can I switch back? Yeah. The first one. Yeah, here it is. Okay. Just to give you a little bit of an idea what Yandex is. So many people refer to us as being Russian Google. But actually, Yandex is a vast ecosystem of different services, tens of different services. And you can also call us not just Russian Google, but we are Russian Netflix, Russian Spotify, Russian Uber, Russian Amazon, and whatever, many, many other things. This is because, of course, in the cornerstone of Yandex ecosystem is Yandex Search, one of the, I would say, very few top-tier search engines in the world. Actually, Yandex was founded 1 year before Google, and we started our history in Russia more than 26 years ago as the first Russian internet index and internet search engine. And we still continue this journey. Russia is very unique in a way that it's still the only country where Google global dominance has been successfully challenged. In Russia, Yandex Search possesses market share of 65%. The rest is Google. And this is, without any exaggeration, the only country like this where we won Google in the fair competition. There is also China, but Google is being blocked there. But search is not, it's a cornerstone of the ecosystem, but not our only service. We also have our own ride-hailing services, taxi, food delivery, we have marketplace, we have very successful video and music streaming services, being also #1 in Russia and neighboring countries. So as I said, lots of different services, the whole vast ecosystem of digital services here and there. But coming back to the cornerstone, so all those services have their roots in our search engine. And we believe that fair competition in search engine is the key to development of digital economy all over the world. So we believe that with the new developments in the regulation here in Indonesia, maybe someday, Indonesian market will also be open for the fair and I would say strong competition between different search engines, including ourselves. Meanwhile, we are doing only the first steps in Indonesia, but hopefully next year we will have a full-fledged kind of start of our services here. Let's see. It strongly depends on the regulation at the moment. What is important that Yandex Search itself, since maybe last 10 years already, is very heavily dependent on machine learning and AI technologies. It is natural language processing, it's image analysis, many things. And as a result, we in Yandex developed in-house our own services, our own generative models, both for images and for text generation. We have Yandex GPT, which is kind of on par with the most advanced GPTs in the world. And we have Yandex Art, our image generation model, which is also on par with such models like Midjourney 2.0, for example. And by the way, Yandex Art is available in our application, globally available in app stores. The application is called Chedevrum, and this is maybe one of the first, or maybe the first in the world, a social network specifically designed for sharing and liking AI-generated images. Very popular in Russia. And of course, we think a lot about ethical grounds of artificial intelligence. And this is one of the priorities in Yandex and in Russia as well. We are doing all together just very first steps in the development of artificial intelligence. And my colleague, Alexander Krenov, will elaborate on this, on the history of AI. But I just need to say very briefly here that ethical development of AI is very, very important and vital, not only for the development of AI as such, but for the whole humanity. We understand all the related risks connected with the development of artificial intelligence. We all watched those movies with Skynet and everything. I should admit that we are very far from that yet. Hopefully, or hopefully not. It depends on which side you are on. But still, the rapid development of artificial intelligence raises a lot of concerns, ethical concerns. We have some set of priorities here, and of course, diversity, transparency, openness in the development of these technologies is very important. We're also aware that the Indonesian government has a strategy of AI development approved by the government and propagated by the Minister of Communications, by Kominfo. And it is very important for such a huge country as Indonesia. AI development has been also stated as a priority, and we will be really happy to participate in developing artificial intelligence and these technologies here in Indonesia. We are eager to do so, and hopefully today's event, today's seminar, may also become one of the first steps on this long journey of development of AI in Indonesia. Thank you again for having us here. We will be very happy to share our experience, our ideas with you, and to listen to your experience and to your ideas. So thank you again, and really appreciate your attention to Yandex. Thank you for this opportunity.
So thank you, Mr. Alexander Popovsky, with the presentation. And I would like to move to the next session. The next session will be presented by Alexander Krainov, who will tell us about the modern history of artificial intelligence. So, Alexander Krainov, the time is yours. So let me explain a little bit about Alexander Krainov. So he graduated from MIREA, and currently he is the director of the development of AI technologies at Yandex. And currently he is responsible for the direction of experimental AI-based products and technologies. Prior to that, he led the development of computer vision products and algorithm at Yandex for 9 years. So prior to Yandex, he worked at Spirit DSP and its subsidiary Seastorm as the product director. He was engaged in audio and video compression and transmission algorithms. video conversion technologies, computer vision, and 3D rendering. So currently, he also head of scientific council of the National Russian AI Prize, head of expert working group on the Russian federal project for the development of artificial intelligence, and he is also a member of the ITMO Supervisory Council, head of master's degree in software engineering at ITMO, one of the prestigious university in Russia, and also a member of the National Russian Commission on AI Ethics. So I spent kind of the time is yours.
Thank you very much. I think it's the best introduction, maybe I listened before. And can I use clicker? No? Okay, we will change slide by voice. But can you show my presentation? No clicker, but what about presentation? Sorry for too many questions. By the way, I would like to recommend you sit more close because some interesting content on my slide and very difficult to see from this distance. No? Come on, I think we will have interesting discussion with you. I will ask you some questions.
Namanya tuh Profesor Ari. Habis ini Profesor ya, Profesor. Jadi habis ini masih belum masih lama ini. Jadi
Okay.
dari fasil.
I'm sorry, can I more convenient for me to stay near my presentation? Can I use this mic?
Okay.
Yeah. It's more interesting to talk this, and sometimes I will need to show something. I would like to talk with you about modern history of AI. By the way, please raise a hand who very close to machine learning area, who study machine learning or computer science. Who of them? Nobody? Ah, okay, fine. I will talk with you. Okay, next slide, please. My story starts from year 2012. It starts from conference, from European Computer Vision Conference, ECCV, which happens in this year in Florence, Italy. And here a screenshot from a website of this event. And here's several workshops from this event. Next slide, please. And one of these workshops is very interesting. I've been there, by the way. And what's happened on these workshops? In these workshops happening worldwide revolution. Have you any ideas what's happened there? No? Next slide, please. Did you know this work, this paper? ImageNet classification with deep convolutional neural networks. Authors Alex Kryzhevsky, Ilya Sutskever, and Professor Jeffrey Hinton from Toronto University. Do you know this paper? No? Okay, I explain you. It's first time when neural networks beats other algorithms for computer vision task, for image recognition. It was image recognition challenge based on a huge image dataset, ImageNet. And next slide, please. The revolution is using this method, error drops from 26% to 15%. It's really huge result, a dramatic result. And the first time, again, when we see huge advantages of neural networks, of video cards, because the solution based on NVIDIA cards, etc. And from my opinion, from my point of view, from this year, we can say that now is a new era of artificial intelligence. And next slide, please. Very many happens after this. Very many interesting works, interesting publications, fantastic results. And my first idea to talk with you about all of them, but we need for this about 3 months. Do you have 3 months from this moment? No? Okay, because it looks like I have only half an hour, and I talk about just some of them. Next slide, please. Next very important paper is word to vector. It's paper about word embedding into space, into semantic space. The idea of this work is very simple. Next slide, please. There are 2 methods. The first method, we try to predict word using words near, using other words. And the second method, we predict words near our word using this word. And SIBO and skipgram. SIBO is continuous bag of words method. And what interesting we get after this? It's first time when we're using neural networks for natural language processing, successful using. This technology lies many years after this. And could you please show next slide? We get fantastic result. What is word representative? Word representative, it's vector. And a multidimensional vector. And it looks like brilliant result, but this vector and components of this vector have semantics means. If we make vector from king word, as example, minus vector from man word from this vector, and plus from woman word, we get vector which will be very close to vector from queen word. It means that we can convert, how to say, text to mathematician space. It's a really brilliant work which give us possibility to make very many interesting in future with text. Next slide, please. Next paper, what I would like to show you is autoencoding variation bias, VAR. Next slide, please. Autoencoder, and it's one of the key technology in artificial intelligence. What the idea? The idea is trained to neural networks, neural network encoder, neural network decoder. What we do? We take some content. It's not important what is this content, what type of content. It can be text, or it can be audio, music as example, or it can be image or video. Encode this into very small vector and decode, try to do absolutely similar as input. Our task, make output absolutely same like in input. This provides us possibility to train neural networks without labeled data. And as a result, we have very small compact representation for each type of data, latent space, which we can decode and receive result. Usually in production, we use just decoder. We generate some random content in our latent space, and receive result. It's this technology using for music generation, for text generation, now for video generation, etc. But this method have one problem, classic autoencoder. Can you please show next slide? The space is not continuous. It means that I take any object in, now please look to the left side. If I take any object in colored area, I get good result. But if I take any color in white area, result will be absolutely bad. And I can't make a transition from one color area to next color area because this space is not continuously. What changed with variation after encoder? Variation after encoder, it's methodology for add some noise for training neural networks. And as a result, we get continuous space. That means that our colored area is very close, and it's meaning in this space, each point means something. And also it gives us possibility to make a transition. You can see some papers about changing of image style. You can switch one image to other, and you can you can receive any points between two images. Or as example, many application for I don't know, for changing age, you upload your image and see how you looks when you're older or younger. It uses this technology. Okay, next slide, please. The next very important work, many also important works, but I try to select best one by my opinion, is ResNet, deep residual learning for image recognition. When first time we meet the term of deep learning, what's deep? Can you please show next slide? Have you any ideas what means these bars, length of these bars? Help me. What means this length? Have you any ideas? No? It's number of layers. It's different network architectures, and this is number of layers. The first neural, not first neural networks, but first neural network which we talk about it today, AlexNet, it's just several layers. VGG 90, obviously 90 layers. GoogleNet, it's GoogleNet because Google with Jan LeCun together. Networks, it's also just same layers. But ResNet, more than 100 layers. After this, after ResNet, deep learning become really big, really deep. And how it works? Very important part of neural networks here is a small block, which two layers and skip connection. And this skip connection is very important. We can skip some layers when we're using our gradients. And after this looks like a very easy trick, we have not any limitation about number of layers. I think you know number now it can be billions or billions neurons in our neural networks. There are a huge number of layers, but all of this start from ResNet. It's still very actual technology. Next slide, please. Do you know about this article, about this event, AlphaGo? It's a very important event in our history. It's first time then computer beats a human in very complicated game Go. Go, I don't know how Go in Indonesian language. In Chinese, it's Weiqi. In Korea, it's named Baiduk. In Japan, or international name of this game, Go. Do you have any specific name on Korean, on Indonesian language, no? But you know this game. Okay. And this game is complicated because number of variation, number of move in this game more the number of atoms in universe. There are no change to using just to using standard algorithms win this game. To use as an example, Monte Carlo research algorithm, which algorithm very usable for any games. But how we humans play any game? It can be Go or chess or other game which you play. We have first idea, maybe there, first idea of next move. After this, we think that, okay, my opponent answer this, and I move this. And we calc our game to the end, yes? But if we meet with bad situation, I play this, they play this, I play this. No, it's too bad for me. I need other way. We try to calculate other way, other tree. What's the problem with algorithms? Algorithms play same way, but algorithms don't have an intuition. And first idea maybe there is random for typical algorithms. What changed after this paper? Next slide, please. DeepMind company, it's DeepMind paper, trained two neural networks. One first neural networks predict next move. How they train it? We take a huge number of played games, take just position from this game, and next move which made in this position. And train neural networks to predict next move. This is very similar for our intuition. Our intuition may be there. We don't calc for this moment. It's just first idea. The neural network after this show this with skill to good idea of next move. The second neural network learn also on existing games and on existing position. They try to understand who's win in this position, black or white. That's all. And now how we use these two neural networks. Alex, are you okay? I ask my colleague because he need to fly very soon. It's okay. Okay. And one neural networks think maybe this move. Second neural network answer maybe, I don't know who is in this position. Opponent maybe answer this. Second neural network says no, it not looks like because it's a very bad position after this. Maybe this. Is this okay? It's start plays very similar like human. And but it's not at all. After this, computer start play like a top players because algorithms learns on games of top players. But when algorithms play like a top player, we can plays many games using algorithms, using computer. And after this, start training processing on new games which played computer himself. Receive new version which play better and repeat it. It means that computer learn on his own games. This technology names reinforcement learning, and it may be the first time when reinforcement learning show a huge advantage compared with other methods. Next slide, please. It was a very interesting event in real-time translation with many PRs. This game with Korean champion Lee Sedol, a game for $1 million. DeepMind company make very cool movie, very cool film from this event with the same name, AlphaGo. I strongly recommend you watching this movie. It's how to say, like National Geographic style, very beautiful movie. And also what's happening in this moment? Sometimes we talk machine learning, sometimes we talk artificial intelligence. Mike, I very like joke that what difference between machine learning and artificial intelligence. In something writing using Python, it's machine learning. In something writing in PowerPoint, it's artificial intelligence. There is a difference. And people use term of artificial intelligence in two cases. One case is it's for very old term for researchers, and its possibility of computer to show cognitivity possibilities like human. But second area where we use AI word is computer games. When you play this as a human, you play with other human. When you play with computer, you say that I play with artificial intelligence. Here, man play with computer. It means that he play with artificial intelligence. And per company start with words artificial intelligence beat human. And next slide, please. After this, we rename machine learning into artificial intelligence. Only after this. This renaming actually, frankly say, increased my salary about twice or more. Because no need to pay many money to specialists in machine learning, but there are many reasons to pay for artificial intelligence. Next slide, please. Next, very interesting works, a very interesting paper, which I would like to show you is GAN, Generative Adversarial Networks. Next slide, please. And we again use two neural networks. It's very common to use two neural networks if you don't have labeled data, enough labeled data. It can be used for many different tasks, but I give you an example how we can use it for image super resolution, for technology, for increasing image size. Okay, takes some random samples, random images, and downscale it. It's very easy. Make smaller images. Try to use any, doesn't matter what type of neural networks, for increased resolution. This is first neural networks, which name generator. The second neural networks name discriminator. As in the input, we use to discriminator one image. Sometimes real huge image, sometimes increased image. Discriminator try to understand, try to predict, is it real image or fake? And if discriminator is correct or wrong, return the result to generator. As a result, we need to say thank you, goodbye to Alex, because his airplane is very soon. Thank you. Okay, let's continue. And generator, as a result, generator try to generate image which discriminator thinks that it's real. Why it's a serious advantage compared with other method, compares with autoencoders. Autoencoder try to make more close with real result. And good strategy in this case for autoencoder to generate something average between possible real variations. For image super resolution, an example, it doesn't work because autoencoder generate something blurred. But in generative adversarial network, task for generator beat discriminator. And generator generate something that can be true. Not maybe that's true, but can be true. One of possible variants. And it's give really perfect result. It's first time then generated images be very beautiful, be sharp. Not in this work. After this work, it's work to show advantages of this method only in MNIST dataset. It's very simple dataset. Next slide. But other work after this, style gunners work from NVIDIA company. This images from work which name this face does not exist. This is not real faces. On these pictures, all these faces generated synthetically, but looks like absolutely real. It's using GAN technology. Next slide, please. And this is style GAN technology to change style of image. And you see that it looks like really beautiful. Next slide, please. Okay, we're very close to today. Next paper is a paper with absolutely brilliant, beautiful name. Attention is all you need. I have t-shirt with these words. Attention is all you need. Where first time we start use word transformer. It's not transformers from movie, it's transformers for technology. It's technology for natural language processing. It's also, it's very difficult to recognize it, but it's also autoencoder technology. This use word to vec and adding autoencoder technology, variational autoencoder, and also using very interesting attention mechanism. What different, at the first, what different compares with word to vec? Word to vec using word around our words, but without their position. In this method, very important also position of this word on all word. And also the idea if you try to understand what means each word, you don't need use all words around. Some words is very important for understanding what this means, some not. Yeah, I think I don't want to describe very many details about each technology because it's very easy to read in Wikipedia as example. I just show you the timeline of technology. This product dramatically increased, as example, quality of automatic translation. Before this, the text which created from automatic translation looks like very difficult to read. Each word translate correctly, but together you can't read it. It looks very bad. After this, translated text looks beautiful. Next slide, please. Next paper is DALL-E. It's paper from OpenAI. It's a paper about text-to-image generation. We can, I think we can say that this paper, it's start of epoch multimodal networks with together processing text and images. Next slide, please. I think you remember these pictures, chair in avocado style. It's first time when we can generate images by text. Next slide, please. Next paper, GPT-3 from OpenAI company, which paper using technology of a transformer, but implement into real huge data set and shows brilliant quality of brilliant quality of text generation. What they do, what they OpenAI do, they take all text from internet and train model, write text like text in internet. Next slide, please. Diffusion models. Next slide, please. The idea is very simple, but it works. What we do, it's for image generation. We take an image and add some noise to the image. This is method for generate synthetic data for machine learning. And try to learn our algorithm, remove noise. Just add and remove noise. After this, we repeat this step. Add image with small noise and add a little bit more noise and remove it again. And several steps. After this, as a result, we have technology which can generate image from noise. We just enter noise and receive image. Next slide, please. And combine all of previous methods together. Works which name DALL-E 2. Next slide, please. The result is really brilliant. You can just print any text, receive image. You can see this similar, very similar work in Stable Diffusion or Midjourney products. It's very common right now, but all of these start from DALL-E 2. Next slide, please. How it works? Very simple scheme. We take a word using transformer, using attention mechanism, receive representation for this word in latent space, semantic representation. We take image and using using autoencoder for generator, algorithms autoencoder, and using discriminator for increased quality, receive an image which was very close to our word. In this paper, we joined all previous technologies. What we joined? We joined word-to-vec, we joined transformers, autoencoder, and generative adversarial networks. Next slide, please. And final paper for today, Instruct or ChatGPT. Actually, most innovations happen in Instruct GPT, but human know about this technology after published ChatGPT. I think you remember how works GPT-3. We learn on text in internet. What's the problem with this technology? There are many bad internet. There are many good texts in internet. Small percent text of internet helpful. There are no text in internet or small number text in internet which start from questions. Next slide, please. How works Instruct or ChatGPT? How learn it? The special people, which name redactors or assessors, answer to many complicated questions. As example, explain the moon landing for 6-year-old child. And they write dozens of thousands text. Answer on these questions. And model like GPT-3, which pre-trained on all internet, now trained additionally tuning for this answer. The model start answer in style like special editor, but it's very expensive, very difficult to write answers. Yes. Next step, model generates several answers on text, and editor choose best one of them. And again, we train like human, but generate text which will be selected by human. And after this, third step, when we collect enough data, enough choosing of human, we learn new neural networks, choose best variant like a human. And now one of neural network generate variants, and second neural network choosing which variant better. It's very, very close to many previous method. And also it's very close to method from AlphaGo. One neural network generate move, and one neural network answer about this position. Is it good move or not? Yeah, and this technology have absolutely same name. It's reinforcement learning, but reinforcement learning with human feedback. Why with human feedback? Because human feedback very usable for learn, for make samples and for make a decision which variant is better. Next slide, please. This is small part about history. Each block there is very interesting, and then I can talk about each block more than 1 hour. And but it happens now it's several years ago. All of this several years ago. Next slide. What's next? Actually, I don't know. We have very many interesting papers about multimodal space using not only together text and video, but also text and voice or text and video. Video is a very important signal. We take more and more huge data. We use neural networks, special tasks like code generation is example, my favorite interesting area of for medicine or for healthcare. It several years more to understand what's most interesting, what important from modern works, from works which from papers which we read right now in the future. And I hope we will meet here again, and we meet here again. Yes? Oh, okay, fine. We will meet here again 5 or 10 years later and discuss about what's interesting happens 5 or 2 years ago. Next slide, please. Thank you very much, and so sorry for I talked too long. Thank you.
So thank you for Alexander Krajnov. From this presentation, is there anyone who wants to ask a question? Ada pertanyaan kah yang mau disampaikan kepada Alexander? Is there anyone? So is that maybe I can ask, okay. So currently, even though artificial intelligence exists in from 60 years ago, we just recently, witnessed its a huge application, right? But there is also another concern about, like, for example, there is some issues regarding the ethical AI, and then also the, using too much energy resources for the development of AI. What is your response to, with these emerging issues? Would it be hinder the development of AI, or will it just, AI will continue to develop?
It works. I think if we talk about AI, it's very similar situation when we talk about computer as example. When computer and internet just come to our life, we also think, is it okay for human or not? Which professions will be cancelled? What happens with people after this? And what we see now, nothing bad happens. I think artificial intelligence, AI, change many in our life. We can't know how. Like we can't know how computers and internet changed our life 30 years ago. But yes, we have some ethical problem, and we need to think about this. And I can give you several examples. One of them, if we talk about generative models, the quality of generation models dramatically depends by size of data set. It means that models which works on English language works much better compared with other languages. Because there are no so many texts, so many like in English text, so many texts in Russian or Indonesian language, as example. And it means that English language gives serious performance. Is it a ethical problem? I think yes. I think yes. And also as example of serious problem for us, that AI gives us very beautiful, very brilliant answers. You very trust to these answers because they look really smart, but actually it's just random generation, token by token, word by word. It can be absolutely wrong. Okay, there is with many hallucinations, and the ethical problem is how to don't give a chance to neural network to answer to the very important questions about life, questions about religion, questions about medicine, etc. And a limitation for this is very important also. And I think that artificial intelligence is not a subject. It's not a character. It's just tool, but it's very new tool and very powerful tool. Looks like computer or nuclear energy or internet and something new in our life. And of course, we need a very precision control, but control not neural networks, control using of neural networks. And if we talk about ethics, we talk actually not about ethic of neural networks. There are not ethical neural networks. We talk about ethics of using neural networks. Thank you.
Thank you for the answers. Are there
I am a king of short answers, yes.
Thank you, Mr. Krenov ya, Krenov ya. I'm sorry, I'm still uh, good condition. Okay, we are very proud that you are coming here, and I'm get to know about Yandex. Yeah, it's very interesting because today in Indonesia we only mostly us know about Google. Yeah. But interestingly, you have Yandex in Russia. Yeah.
By the way, we are 1 year older than Google.
Yeah.
We start early.
Yeah. Yeah.
Yeah, 1 year before.
Yeah. So I'm the chair of Department of Mathematics in this faculty, chair of Data Science Center as well. So many projects in our student now, we working with data science and AI application, yeah, in real life problem. And especially today, we are going to work more about generative AI and also large language model. Yeah. But as you know, the problem is the computing power. Yeah, because if we build more complex AI, we need more computing power to train our model. Yeah. So now we can do this using like Google Colab and so on. But if we want to generate more professional, more real applications, we need more computing power. That is the main problem. Besides the model we develop, the other side is we need more computing power. Actually, in our university, we has proposed to develop the new center, including the computing power, but the process is very slow. Yeah, as you know, it's in our government is very like administrative process is very slow. Yeah. Maybe my question is, for our collaboration, is possible that we can get support from Yandex about the computing machine,
Yeah.
power that we can use, especially for our student or our research. Yeah, that's it.
Yeah,
Thank you.
yeah, I understand the questions. Let me answer. And short answer is yes, it's possible. And we have, in Yandex, we have Yandex Cloud. And we have some program in Yandex Cloud which grant to universities for very, very special price, for commercial price, using our platform, using our clouds, using our computer power. But also, I would like to say that it's problem common for all world. We in Yandex have not enough computational power which we want. All companies in the world have not enough power which they want. We need more computational power. It's commercial company with many money. What about universities? Universities have not enough money. And only one solution how solve this situation in our country is building data centers, huge data centers, on government investment, on government money, government data centers, for provide free access to these data centers to universities. And in Russia, we just start, unfortunately too late, we just start this program. In China, as example, I know they build very huge data center, which named Piancheng, it's near Shenzhen, with huge computer power. It give access many universities. Only one condition: all what do on these data centers must be published in open source, must be open, and give access to for all universities, not only for universities, and some for some open source community. This is important way to the country. But remember my first answers. Yes, we can discuss about this, you know, do the contact, and we can discuss about using Yandex Cloud for your needs. Thank you.
Thank you for the answers.
One more video.
Okay, thanks for the the solution, the solution, actually, we know that the solution must be from our government, so the government need to provide this, boost this, the process, the progress of this AI development, we hope that, but the problem is in our government, they have different thinking about infrastructure. They just see the cost, but the outcome. This is the problem. How we convince our government. That is different. Maybe with Russia and other maybe developed country, they already know that. One joke, I get one jokes when I visit one of the developed country. When I see, and I visit their national high performing computing facility, they said that if you want to know that your country is already developed, just see in the top 500 list. If your country get the number in this list, that means your country is already developed, something like that. So that is the problem, but we're still fighting. And actually, last year we proposed by our proposal to our government to develop a high performing facility in our university as the biggest happiness center in our country, and we fight for this proposal. And
okay, I have two answers. The first, my opinion is, come on, it's my first visit to Indonesia, but I see Indonesia, it's very top country. Trust me, it's very top country. Indonesia is very top country. The first and second, what I want to say, if you next time go to government to discuss about needed AI strategy or investment money to AI to data centers, bring me with you. I will help you to make some advice to your government.
Okay. Yeah. Thank you very much.
Thank you.
So I would like to move on to next session. So for the next session, I think it will be presented in bahasa. Okay, so for the next session will be presented by Pak Muhammad Hilman, PhD dari Fasilkom UI dan dari tim project Ristek UI. Kepada Pak Hilman dan tim project Ristek UI bisa kami persilakan. Sebelumnya izinkan saya untuk menjelaskan sedikit profil dari Pak Hilman dan tim proyek Ristek UI. Pak Hilman menempuh pendidikan di Universitas Indonesia dari tahun 2006 sampai 2010 dan memperoleh gelar sarjana di ilmu komputer. Dan dari 2010 sampai 2012 beliau juga menempuh pendidikan master juga di bidang yang sama, lalu menyelesaikan pendidikan doktor di bidang cloud computing and distributed system di University of Melbourne. Saat ini beliau adalah peneliti di CCSI Universitas Indonesia, juga peneliti di Laboratorium Sistem Komputer di Universitas Indonesia, dan juga menjabat mengajar juga di Universitas Indonesia. Lalu untuk tim Ristek UI sendiri, ada beberapa penghargaan telah mereka raih, diantaranya juara kedua Data Mining Gemastic ke-16 tahun 2020 pada September 2023 kemarin. Juga juara pertama tantangan Big Data ya, Satria Data yang diselenggarakan oleh Pusat Prestasi Nasional yang diselenggarakan pada Agustus 2023. Lalu pada Oktober 2023 juga memenangkan juara kedua Objective Quest oleh FTMM Unair. Dan juga dan menjadi pembicara di focus group discussion on the utilization of artificial intelligence for harmonizing legal regulation with Assistant Deputy for Policy Material Management di bidang di Sekretariat Kementerian Menteri Sekretaris Negara. Pada Pak Hilman dan tim bisa dimulai. Thank you very much, ladies and gentlemen. I've seen several faces here that's very familiar to me, Professor Luar, Professor both of them are also supervising my work since my undergraduate years. So let me introduce myself. My name is Muhammad Hilman. Currently, I'm the director for Computer System Laboratory, which includes the High Performance Computing Group, Computer Network Group, Big Data and Technology, and so on. And also, I'm part of the cybersecurity and cryptography and Indonesia. So I spent my bachelor degree here with Professor Bersiaplah, and then my master as well. And then I take my PhD from University of Melbourne with Professor Bersiaplah, one of the common products for the cloud systems in Portofolio. Okay, so basically here we should introduce the team from the Students Club instead, but also I will present a very related topic to AI, which probably when you guys talk about AI, you will never heard of this topic. But actually, the backbone of the AI itself cannot be realized unless we got this technology. Well, Professor Alhadi just
mentioned in the question before, like we don't have computing power and so on. So what are computing power and what are the, kind of the main point for the AI related to computing? Because that's what I really want to talk about. And before I wanted to, talk about the topic. So here is the student club of the Department of Science. So basically, this packet independent studies, independent student club specifically work on or have the interest group on several aspects of computer science, including AI, science, network security, and also UI. So they will present their own work in student club related to AI. So that are two topics that we will cover in this one. Okay, we talk about AI a lot since the beginning of this seminar. You guys heard a lot about AI. What are the technology, what are the algorithms behind those? Maybe we should shift a little bit about what actually is the high performance computing, the technology behind, the amazing, the great of AI, how the algorithm work, how they process the data, and so on and so forth. So basically, we are using the HPC for, process the workload, process the data, that kind of take every whatever type of it, and we create the computing power. Because you can imagine that if you process those kind of data within your own laptop, we will not be able to process it. We have several examples here. There are the left one is image processing. We can process the imaging of medical info like MRI, CT scan, and so on. We can process those images and do some analysis. Whether can we detect there is any disease with this information? Something. And we can also use, this computing power to model the to simulate the molecular activity. This one is part of the years ago, modeling the molecule to discover new drugs. So we can model how they working with the inhibitor and how this kind of activity can be analyzed for the future drug product, for example. Or maybe the newest technology that probably has been introduced by the previous speakers, image face recognition, object detection, the technology that you guys work using like automatic, like automatic identification biometric, automatic vehicle. How can they see the world and how they can detect any kind of information around them. So basically that's part of the computer vision and image processing. And those are to realize that kind of process, we need some computational power, of course. Okay, next. Okay. In terms of the research, we can do many things using the high performance computing. We can do advanced simulation. I believe most of the activity in Faculty of Math and Natural Science here are working to simulate any kind or to model any kind of problems around your expertise. And for this kind of simulation, for this kind of modeling, you will be needing a very huge computing power. To model the climate, to simulate the molecular dynamic, to capture astrophysical phenomenon, all of them are needing the computing power. And I believe you guys probably try to run this kind of simulation on your laptop, and I believe it won't be finished, in a measurable time, like 1 hour, 2 hours. It may take, days to finish that kind of simulation probably. And that because your computing power in your own PC is not that, powerful to do this kind of computation. Data analysis, of course, genomics, particle physics. Well, in terms of that analysis, we won't talk about like 1 megabyte, 1 gigabyte of data. But of course, 1 gigabyte of data is considered big anyway. But in this time of, world, we have the order of data in more than petabyte and zettabytes, especially when we talk about the data in the internet. So that's why if you guys using your own laptop to process these gigabytes or petabytes of data, I don't believe your computer will able to process all those data. Even to load those data into the memory will not be possible if you are guys using your own laptop. Okay. And by embracing this kind of technology, the high performance computing, we can achieve the interdisciplinary collaboration. Because we, as a computer scientist, we can provide, we can design, we can serve as the backbone for this kind of power. And then any expertise you guys working on, be it in the physics, chemistry, biology, and whatever it is, when you guys needing the computing power for simulation or modeling some kind of problem, well, we can always do this kind of processing with the high performance computer. And I believe the last one, many prominent researchers in the world hesitate to come to Indonesia is because one of these reasons. We don't have the facility to serve their problem, to help them to work on their own research area. Like biologists, chemists around the world, maybe we'll think twice when they decide to go to Indonesia in terms of whether Indonesia have the capabilities to provide, this kind of simulation or this kind of modeling thing. Okay, so that's why in terms of research, this is like a must to have for any country. In the level of the country, of course, not in the level of the university. Yeah, next. The other thing, because we are in the teaching institution, the university, by having this kind of facility, by acknowledging, by mastering this kind of technology, we can have many advanced teaching potential. We can have more advanced course development because whenever you guys teach something and it is related to the order of the big number of the data to be processed, we can easily, teach you how to process this kind of amount of data with having this kind of facilities. Okay, so basically these are the opportunities of us to master, of course, this technology. Okay, next, Mas. Okay, as FYI, for your information, how's the current Indonesia landscape regarding the computing capabilities? Well, this information I've got from the Ministry of Education. They said several institutions have this kind of machine in their campuses. Well, we have the one of the AI HPC facility in Faculty of Computer Science. We got 2 DGX version of the computing capabilities. Several universities also have. So they claim that we have 46.5 petaflops computing capabilities in Indonesia. But have you ever heard the advancement of AI from Indonesia? So this number didn't represent the actual, capabilities of the AI Indonesia because of what? Because these facilities didn't, didn't supported by the human resources from the university itself to utilize those power. So how many of you university students have utilized these facilities the University of Indonesia has? Just a little bit, I believe. Most of the time, the problem is not because we cannot access the facilities, not because we cannot access the machine. But the most of the problem is we didn't have the ability to design, to create software, algorithm that can be actually utilized this machine. So that's one of the aspects that has to be considered by you guys, students, to prepare yourself. Actually, in the newest slide, I prepared what are the you guys are having to have, are must to have to embracing this kind of technology. But well, anyway, let's go to that section later. Next, please. Okay. This is the top 500.org that mentioned by Professor Al-Hadi before. So this is the record of computing capabilities for each countries in the world. Well, if you cannot see this is too small, you can go to top500.org yourselves. So currently, of course, as we can see from this pie chart, most of the computing capabilities are owned by United States. Several countries, including China, rising little by little to develop this kind of capabilities itself. Japan, France, UK. This is, I take from the November 2023 version of top500.org. And where is Indonesia? Of course, we are not there. But if you go through this list, you can see that there are two neighbors of us within this 50 countries with computing capabilities. Those are Thailand and Singapore. So basically, Singapore and Thailand has been included into the list. So basically, they have the capabilities. They utilize the capabilities. They measure the the infrastructure they have, and they submit their report to the top500.org. So many people around the world can recognize those capabilities, right? So the one important aspect that we have to achieve, we have to prepare is we have the infrastructure. That's one thing. The other thing is we have to prepare our capabilities to utilize those machines to create something, beneficial, and let the world recognize our capabilities. Okay, well, next, please. The top500.org predict that in the next 2 years, the computing capability will always increase. Of course, because the rising of the artificial intelligence technology, of course. And we don't want to be left out, right? Because of our incapabilities on utilizing this infrastructure, not only by by not having the infrastructure at this time, but also our incapabilities to pursue the skill sets needed to utilize this kind of technology. So procuring the infrastructure is the government side. They are the one who are responsible for procuring such infrastructure. But as students, academics in the University of Indonesia, what the thing that we should prepare? We have to prepare the skill sets needed whenever later the infrastructure is provided later on, sometime in future. Okay, next. Yeah, this is one of the Professor Al-Hadi mentioned about proposal to develop AI center. This is one of, I took some of the image from the proposal. So by having this kind of infrastructure, what can be done with us within University of Indonesia? We can do many things. We can do AI, of course, that one of the thing that we are talking in this room. Geographic information system. If you guys, some of you guys from the geographics, robotic swarm intelligence, medical bioinformatics, LLM, of course, for training as well, of course, vision, and so on and so forth. So the question is, have you prepared yourself, to embrace this technology whenever this technology comes to us, sometimes in the future? Okay, next. Okay, more detail if, let's just say, if we have the infrastructure by now, we can do what we can do with those kind of facilities. Okay, of course, to simulate, to model to do the simulation, we can actually handle large data sets, and we can speed up the process to process those kind of large data sets, and so on and so forth. This is just one of the example of it. Okay, next. And also other things, probably you guys want to work on the computer vision, for example. Yes, we can do. And there are problems that lies on the computing or computer vision aspect that can be solved whenever we can utilize this kind of infrastructure. We can do high dimensional data processing. You can do feature extraction, and so on and so forth. So regardless the large language model, of course, they train more than millions of parameters with very large data sets. We have to, can you imagine how big the computing power or the compute that we can that can process that kind of problems? Of course, we have to get a very big infrastructure for that kind of scenario, right? So that's why by having this kind of infrastructure and by preparing ourselves for the skill sets needed for this kind of infrastructure, well, I hope sometimes in the future we can, utilize more and see more result, the advancement of research, be it in the your area, in natural science, in natural language processing, in computing, and whatever it is, by utilizing this kind of infrastructure. Next, I think that's all. That's all for my short talk for this session. Thank you very much, and thank you so much.
I have a questions. Can you show a slide with performance with the different with performance computers in Indonesia?
The slide.
Okay, how you calc this performance?
Sorry?
How you calc this performance?
The top 501. The list. Oh, 46 petaflops something.
Yeah.
Okay. Okay. Can you, Mas Fahmi boleh?
Previous.
Yeah. The government slide one. Yeah. Okay.
No, before.
No. The earliest slide about
Early.
petaflop. Okay.
Yes.
Okay. Yeah.
How you calc this?
Okay. These slides I literally take from government slide. So I myself, I question this slide.
I hear one mistake here.
Yeah.
You know,
Okay. Yeah.
it looks like you take petaflops
The number of
from
machine.
NVIDIA
NVIDIA
from
machine.
NVIDIA.
Yes, the NVIDIA claim machine.
You know what the problem with this petaflops? It's FP
Yes.
60. When you measure
Maybe
when you measure use
yeah.
lean pack test in top 500, you use FP 64.
yeah.
Floating point 64.
Mm.
NVIDIA on his data set shows just FPS.
Just the GPU one. Yep.
It's a reasonable. Why not? Because we train our models FPS 60. But if you compare with other computers,
yes,
it's not true.
Yeah,
And also one more important point: can you show graph supercomputers by
top
country?
500.
Yes.
Yeah, the top 500.
Next slide. Can you show next slide?
You can see the number is not adds up.
Maybe I can add something. Yeah. We have problem with this last time with our government. When I submit our proposal, they said we already get big.
Yeah, we have only same situation. We have only same situation. It's very common for all countries. Yeah, it's very difficult to explain what's the difference between FP 60 and FP 64. Yeah. And can you show next slide?
Can you go to the pie chart thing in top 500?
Can you show next slide?
Next. You can see that the number is.
Yeah.
You can see the number. Yeah,
That-
the number is not adds up.
Yeah, yeah.
There are no Google computer
Yeah.
in top 500 as example.
Yeah, yeah.
Who usually show his computer on this rating? Usually it's company which provide access to his cloud services or universities. Many big commercial companies don't show this. We do this, Yandex. It was just interesting for us. And we do it one time. Now we have more power computer, but we don't measure again it in we don't do this again in top 500. And you see Russia, more than half of them, it's Yandex.
Oh, not the government.
Yeah. What I mean a real picture is unfortunately more bad when we talk. Difference between top countries like United States and other countries is much more. And also, by the way, if you try to something about a Chinese supercomputer for academia, Pencheng data center, as I say before, you can see really huge number of petaflops. But by the way, they use Huawei hardware as center,
Optimized.
and they also calculate it in FP16. They digits in top, their result is in top 500. It's okay, but what they say about his academic data centers, which not in top 15. It's actually not true because it's actually also in floating point 15.
Okay, thank you, Alexander.
Thank you.
Masawi, can you go back to the government slide? So,
it means that I am completely agree with you. You know,
that's right. So my question as well is, if we have 46 petaflops of computing capabilities, what are the Indonesia produce for the world? We don't have one. So that's one of the thing that we have to mention in here.
Yeah, that is a problem when we submit our proposal. Our government said that we have computer power.
Yeah,
and then we argue with them, and we calculate again, and ask from some high performance computing scientists, and then we get only 0.0015 petaflop. That is exactly. The kind of the company brainwash or government official, something like that. That's the problem.
And also one more, not only processors problem, it's also a huge problem is network. If you buy many NVIDIA DGX, as example, also to buy Mellanox.
Yeah.
It's also a huge problem because now it's very complicated to buy Mellanox because there are no in open market. In each time it's very complicated discussion with NVIDIA.
Yeah, that's interesting. And thank you so much. All right. So what's next? For the next session, we will hear the presentation from the team project Ristek UI. So please welcome them.
Okay, can we start?
Yeah.
Okay, good afternoon to all individuals that we really honor. In today's sessions, we are going to talk about one of our innovations that has led us to win one competitions that held by the Ministry of Education, and also has led us to be covered in several media outlets and also being invited to the ministry. So before that, let me introduce ourselves first. My name is Brian, this is Oi, and this is Nyo, and the three of us will be presenting about our innovations today. And without further ado, let's start this presentations. Next. Okay, so what we are presenting is about an innovations in the law field that we call Legimet ID, an AI-powered partner for a legislative document test. Next. And okay, so firstly, we all know that legal regulations plays an important role to provide clear regulations and to organize its society. And in Indonesia, by 2023, there are in total of 57.6 thousand regulations in Indonesia. However, 4.8% among those regulations have been invalidated due to several reasons that we will discuss further in the next slide. And there is also one government figure that stated in every court session, an average of 100 to 200 local regulations are invalidated. Next. And then before we delve into the solutions, we would like to give some backgrounds about the law in Indonesia. So in general, there are two law sources in this world. So the first one is the statute law. It is the law which Indonesia adhere to. And the second one is the common law. For example, US adhere to this type of law. So the main differences between those two laws is that statute law is based on written form of law. For example, like if a lawmaker has made a law, they introduce a bill, and if it is voted and passed, it will become a new regulations. Otherwise, it will be invalidated. And meanwhile, the common law, it is not based on a written law. It is based on the judge opinion. So basically, this is like a judge-made law, but it is not like they could make up the law by themselves. It is also bounded by the prior case of this type of law. Next. Okay, so and then we have 5 main stages in the legal document creation process in Indonesia. But what I want to highlight is the second stage, which is called drafting stage, and it has a regularization harmonization phase. And this is the phase that we will delve into in our presentation. Next. Okay, so in that harmonization phase, our goal is to ensure no contradictions among those clauses, both semantically or even contextually. So what are the example of the contradictions that appear in the clauses? Okay, maybe I will give some example. For the first row that could be seen from this table, it's stated like this: every taxpayer has the right to tax amnesty, and the other ones say that only some taxpayers that has the right for the tax amnesty. We could see here that it is clear that those two sentences is contradicted. And this is usually called contradiction semantically. Meanwhile, the second row, we could see that the first example says that every child has the right to receive a quality education. Meanwhile, the other one says that students who can afford the tuition fees will not be admitted to the public schools. Actually, these two examples, we couldn't infer that example is contradicted if we don't know the context of those two sentences. So this type of examples is called a contradicted clause contextually. Okay, so this is the problem that we are going to solve with our innovations. And so what are the problems? So the first one that we have stated earlier is this one, the contradictions. We know that process of producing the legal documents is very hard, and it is prone to errors like these contradictions. And also, the process of manually harmonizing or checking if there are any contradictions among the clauses will take a long time if it is conducted in manual. And the third one policymakers will waste their times if the new bills that they introduce become invalidated. They will waste their time, and also they will waste their costs as well. Next. Okay, so the question is, how do we solve this kind of problem? And specifically, to what extent contradictions on clauses can automatically predicted? Next. So this is the complications. So what if we are trying to leverage the AI technology to assist this type of technology? So AI technology actually could be used in assisting policymakers or even the constitutional courts to addressing those issues. It could reduce the process of manual checking, and also it could reduce the risk of the conflicting regulations. Next. And based on those problems, we introduce you to Legimet ID, an AI-driven legal textual entailment techniques that could evaluate the consistency among those clauses in the documents. So what are the benefits? So actually, these AI tools, of course, could save the time compared to manual testing on all of the clauses. And also it could identify potential inconsistencies or contradictions among those clauses. And it also could streamline the regulations creation process. Next. Okay, I think before this one, I think there's a slide again. Okay, so who are the target market? So there are two main target market. The first one is the constitutional courts, who is responsible to ensure there is no contradictions among the laws. And the second one is the policymakers, who is responsible to make the regulations and also to prevent the contradictions in their law. So this type of innovation could assist them in reducing the process of manually checking the harmonizations of the regulations. And it also could assist them to avoid the conflicting regulations among those clauses. Next.
Right. So earlier we talked about what we want to do, right? So how can we achieve that? Here are our 4 features that we will use to achieve the target of harmonizing legal regulations. First off, we have generative summarization, which can condense legal documents into concise summaries that are easier to process. We also have statute law retrieval, which employs a search engine to identify relevant documents to the document we're inputting. We have document processing, which can transform unstructured documents into structured formats so that we can analyze them better. And last and most importantly, we have legal entailment, which can evaluate consistency amongst clauses in legal regulations. Next. So this is our process flowchart. First off, you'll see that we'll input a document, which then, using statute law retrieval, we'll find the top and most similar documents based on our database. Then we'll process the original document along with the retrieved documents and convert them to paragraphs that are broken down. After that, we'll match the paragraphs from the original document to the paragraphs from the retrieved documents, and we'll get the most similar paragraphs to save computational time. Then, using a pre-trained LLM, we'll predict the paragraph alignment to see whether or not they contradict each other, which results in our result summarization, and that overall is what we here call legal entailment. Next. So first off, generative summarization. What does it do? It takes a long legal document and generates a concise summary using artificial intelligence. In this particular case, we use large language models such as GPT. Next. We also have statute law retrieval. This is where we use a search engine to retrieve legal documents based on the query, which in this case, it is another legal document. We use a cascade model here, with text matching based retrieval, such as BM25. And after retrieving these most similar other documents, we can re-rank them using neural text encoders. Next. We also have document processing, which is a vital step in our process because originally the unstructured and still in the forms of PDF, right? So we use this to convert, we use natural language processing, such as parsing and name entity recognition, along with a couple of regular expressions, to convert the documents into, let's say, CSVs or tables, which are like document name, title, and it breaks them down by section by section. Next. So legal entailment. Legal entailment takes in takes in two paragraphs or clauses and then labels them to indicate whether or not there are contradictions in there. It uses, well, legal textual entailment by using several transformer-based models such as BERT-based models or large language models as well. Next. So here are a couple of our prediction examples. As you can see in the first row, these two clauses were predicted to be contradictory. And after we checked with the government database of like not inactive regulations, it turns out that these two clauses were actually contradictory and the model was correct. We can also see that in the second row, these two sentences are extremely similar, except for the amount of months. And well, that makes sense, right? Like one person says A months, the other person says B months, and that's why the two sentences contradict each other. So based on our preliminary results with 200 testing data, which consists of 185 pairs of non-contradictory data and 15 pairs of contradictory data, we find that our model correctly predicts 184 out of the 185 non-contradictory pairs and correctly predicts 11 out of 15 of the contradictory pairs. One disadvantage of this model, however, is that because we break down the documents into clause by clause, we can't capture contextual relationships because all we have are the sentences that we're given. Next. So what's next? What could we do to improve all of this? Well, first of all, we could obviously improve the model with more robust and better models, along with a broader scope of legal regulations. We could also get more pairs of contradictory and non-contradictory clauses to train our model better and have it handle everything just a little bit better. We can also deploy an application, or we would also like to include additional legal context from other sources, not just from written regulations. Next. All right.
Okay. Thank you. Now we have reached to the end of our presentation, which is demonstration. But before we start, I would like note that this project is still undergoing development. Okay, next. So as you can see here, our application name is Legitimate ID. They have 4 functions, but today's topic, we will talking about legal entailment. So you might thinking how legal entailment works. So next. So the first thing you might to do is upload your document. Next. And as you can see here, you will be able to see that your document will be uploaded yet. Next. Okay. After we upload the document, we will see behind the scene process. As you can see here, this one is the content of our document, and it is not visible in user application. So yeah, what we are going to do is to find the most similar content with our document have been uploaded before. Okay, next. Yeah, as you can see here, all of this most similar content will be retrieved. And these two kind of example about the most similar content that we already been retrieved. Next. Yeah, just want to clarify that input document is a document that we uploaded before, and the query document has the most similar content with our uploaded document before. Next. And after that, we will parse and break it into some clauses. As you can see here, we'll be parse and break it into some clauses. Next. And all all of the clauses will be matched and paired. And as you can see here also, the input document and the query document. These two are including the content of input documents and the query document. And you might thinking, what are we going next? So yes, artificial intelligence helped this project very well. So we built AI model to predict these two articles, these two contents are in contradiction to each other or not. So what purpose do we do? It's because we want to show that these two articles are in contradiction to each other or not. Yes. Next. So we built our model, we fine-tuning a little bit, and boom. And the model will predict our input. And as you can see here on the first line, these two articles are in contradiction. And also on the display, we also can see that 0.76 or 76%, the model pretty confident about our two articles are in contradiction to each other. Next. And finally, all of the prediction result will be analyzed and summarized. Next. Okay, that's all about our presentation. We have seen that AI has the potential to build and maintain our Indonesian legal system. We hope to develop much further and fulfill its purposes. Thank you very much.
Thank you for the team Project Research UI for presenting their projects. So, from the audience, is there any question that you want to ask to the team Project Research UI or maybe to Pak Hilman? Please.
Thank you, Mas Oi dan tim Kevin ya. Oke. Saya dulu pernah di PricewaterhouseCoopers sama Ernst & Young. Dulu saya di tech consultant. Seringkali kita problem gitu, kan peraturan pajak berubah-ubah. Itu bedanya kalau peraturan lain masih mending, kalau dulu tuh pasti sangat nggak pasti benar gitu. Bisa peraturan, misal udah 5 peraturan. Kita megang nih sebagai, misal dari orang PwC, udah yakin megang peraturan nomor 5. Terus dikasih orang pajak peraturan yang dasarnya pemeriksaan dia ada 3. Buat teman-teman yang lain, orang pajak tuh punya powerful. Ada suatu kasus, dia berdasar regulasi disebut namanya peraturan 3. Padahal peraturan 3 itu memberatkan wajib pajak, menguntungkan si pemeriksa pajak. Ini saya mau confirm, ini sudah dipakai di pajak ya kalau nggak salah, di Fasilkom? Belum? Kan tadi ada legal tax gitu. Oke. Menurut saya sih, kita bisa ngobrol banyak nanti untuk implementasinya dipakai di beberapa consulting firm sih menurut saya. Ini udah dipakai di mana? Di consulting legal seperti apa? Misal kantor hukum mana, misal anak via Puanggawa, misal atau gimana pengalaman Mas?
Oke, ini bahasa Indonesia atau bahasa Inggris?
Bahasa
Indonesia. Oke. Sebenarnya kalau untuk project ini kita udah pernah develop, tapi masih under development juga. Kita pernah buat small scope-nya, tapi masih dalam small range juga untuk dokumennya gitu. Kemarin kita pakainya khususnya untuk di dokumen investasi. Tapi sekarang kita lagi
legal investment.
Belum ke perusahaan sih, kita masih memakai dokumen yang specifically untuk investasi gitu. Tapi
Tepatnya investasi di mana nih bidangnya? Apakah saya dulu di perusahaan investasi juga? Saya di reksadana kah, di saham kah? Itu investasi di capital market atau investasi di sektor real, misal tambang atau apa? Karena investasi ada 2, capital market sama di sektor real.
Oke, jadi sebenarnya kita sampling beberapa dokumen yang konteksnya itu tentang investasi gitu sih Kak. Jadi kita belum spesifik ke suatu investasi yang mana segala macam belum gitu. Tapi kita masih pakainya sampel dulu untuk kemarin tuh kita cuma mau testing dalam scope yang kecil. Nanti kalau misalkan kemarin udah kita sempat coba, sekarang kita baru mau coba develop scope kita lagi supaya lebih besar dan supaya bisa arahnya tuh konteksnya udah bisa lebih jauh gitu.
Berarti di situ ada harapan bisa dieksplor lebih lanjut. Ya nanti kita mungkin bisa ngobrol kali ya setelah ini. Oke. Ya, terima kasih.
Thank you for the first. Thank you for your presentation. It's really interesting. And as I am correct, understand? Can you please show slide where you show the how to say the what advantages, what implementations give your system? The first one is a show. The first one show legal, show similar legals, yes, and second to the table these cases.
The table with the
Cases. There's
Cases.
the two two cases where
oh, okay. Back. Back.
back
Back.
before demonstration.
This one?
No.
Eh?
Before the two advantages which you give your system. How people can use your system for what?
Oh. Back. Back. This one?
Yeah, this one. For my experience, there are, how to say, there are one more case where very easy raise the money. Easy, very close to market. Processing of legal action is very expensive. And sometimes company which want to start legal actions try to understand, try to predict, is it be successful or not? Because they need to spend many money for this processing. And very, how to say, very clear product, the product which predict by act, can it be successful or not? And seriously keep money for company. No need to start, don't need to start act which can be successful. And this solution, I think you can add to market target. Maybe now number one in the market target list is really very usable. If you come to big Indonesian, not only Indonesian, but okay, an Indonesian company, and say, we can give you a service, just one click, you upload your judgment actions and return prediction from our system, can it be successful or not? You can decide, do you need to start or not? And it seriously can keep the money. It's very effective, can be a very effective solution.
Okay, thank you for the advice. I did just I do understand, like you meant that one of the best target markets would be companies that want to check whether or not they want to start legal action, right? Correct?
Yep.
Yeah, okay. That's actually very insightful. Thank you very much, Mr. Alexander.
I know several startups, successful startups which do this. I know one country where it's implemented into government area, then they receive legal action, they can do very fast response, that probability of success of this action. And this, would you like to continue or not?
All right. So actually, currently we are in the process of thinking of those things too, whether we want to continue to start up or not, because our concern is this type of innovations is not that easy as what we expected earlier. I think it is, we could solve this in just a matter of months or years, but I think it will be longer than that. So, and our concern right now is, I think, the resource, firstly, because the resource such as like GPU or maybe the infrastructure or funding and the other else, it is also one of our considerations. And also the other considerations is the human resource itself, because currently it is just 3 of us who develop this type of innovations. So if we could maybe get further support or further human resources regarding these innovations, I think it is very possible to continue this type of innovations.
If we talk about hardware resources, it's strange words, but it's very cheap. I can explain you. You have your pre-trained model. You don't need make new pre-trained model. You just first time you need to do fine tuning. It's very easy. It's classification task. It's very easy. This is if we talk about train, and it's very fast in inference. You just calc one embedding. It's not a generative system. You of course you need to train a big model, but you already do it. The trained in generative model, and after this fine tuning and inference, it's very fast and easy.
I would just probably like to add one thing. So in our current development, we've only used a couple dozen, right? Yeah, a couple dozen of legal documents, and all of them are related to investing, right? And as it turns out, as we not discovered, there are there are 57,000 currently active legal regulations in Indonesia. So we would need to scale the model up by a couple orders of magnitude.
Okay, thank you. And I would like to say that you are absolutely brilliant team. Very interesting for me to discuss with you. Thank you.
Thank you very much.
So thank you for the question and answer session in the session. So I would like to move to the new session, which will be brought by Professor Arya Noir. Please, Professor Arya Noir, for your presentation. So I think I will switch to sorry, Mr. Alexander Krainov, I will switch a little bit to bahasa. So mungkin kayaknya agak ini ya, agak mungkin buat ini jangan lupa minum ya, biar kita bisa bisa menyimak gitu ya dengan baik. Jadi izinkan saya untuk untuk memberikan informasi sedikit mengenai profil dari Profesor Ari. Saat ini Profesor Ari Yanuar menjabat sebagai Dekan Fakultas Farmasi di Universitas Indonesia. Dan latar belakang pendidikan beliau itu mulai pada tahun 1990 beliau memperoleh gelar sarjana farmasi dari Universitas Indonesia dan juga sekaligus memperoleh sertifikat keprofesian sebagai apoteker farmasi. Lalu pada tahun 1996 beliau memperoleh gelar magister di kimia farmasi dari Universitas Gadjah Mada. Dan lalu pada tahun 2006 beliau memperoleh gelar PhD dalam bidang struktural biochemistry dari Nara Institute of Science and Technology di Jepang. Pada Profesor Arya Noir, kami persilakan.
Thank you for the introduction. Good afternoon, ladies and gentlemen. Alex, good afternoon. So let me try to explain in bahasa Indonesia. I prepare my presentation in bahasa. Oke, terima kasih saya sudah diundang Pak Roni untuk membawakan materi sedikit ya, sebenarnya tentang kebutuhan AI dalam industri farmasi. Apa sih industri AI dalam industri farmasi? Utamanya untuk meningkatkan inovasi dan efisiensi ya. Selain saya ditugaskan sebagai dekan, saya juga sebagai kepala laboratorium Biomedical Computation and Drug Design in my lab ya. Utamanya kita melakukan simulasi biomolekuler. Juga sekarang sudah masuk ke penggunaan artificial intelligence. Juga kerjasama dengan Fasilkom ya. Next, ya. Next slide. Oke. Jadi sebetulnya banyak AI, model-model AI ya. Terminologinya mulai dari machine learning, deep learning, natural language processing, robotika dan otomasi, prediksi dan optimisasi, sistem penyaringan dan pemrosesan data, pemodelan prediktif dan simulasi. Nah, ini semua paling tidak ini banyak bersentuhan dan dalam beberapa tahun terakhir ini sudah digunakan ya dalam industri farmasi, utamanya di luar negeri, dan juga penelitian-penelitian di bidang penemuan obat. Mungkin kita akan masuk satu persatu saja dengan memberikan beberapa contoh. Soalnya dengan contoh ini mungkin kita bisa melakukan apa semacam kerjasama ya, karena kami di sini dari farmasi tentu membutuhkan kerjasama dari Fasilkom sebagai case-nya ya. Kita mempunyai case, cuma mungkin kita tidak bisa menyelesaikan permasalahan itu. Mungkin nanti dengan Fasilkom, dengan matematik, kita bisa sama-sama bekerja sama menggali dan melakukan penelitian di sini. Ini dengan Pak Al-Hadi juga saya sudah melakukan penelitian kerjasama di AI ya. Dengan Pak Ilman juga sudah lama kita melakukan penelitian di simulasi waktu itu ya. Awal-awal di simulasi. Tapi sekarang simulasi itu sudah bergeser ke AI. Karena simulasi itu mengambil porsi yang besar pada compute time-nya, menghabiskan resource. Sedangkan begitu AI di training dengan data yang banyak, dia akan memberikan model prediktif. Dan ternyata model prediktif dengan model hasil simulasi akhirnya jadi dekat. Dan ini sudah dibuktikan oleh AlphaFold ya. Dan kita gunakan AlphaFold sebagai model sekarang. Karena model prediktif, dan sekarang AlphaFold itu hasil prediksinya sudah masuk dalam protein data bank. Di mana protein data bank itu adalah hasil eksperimental. Kita banyak sekali menggunakan data dari protein data bank. Beberapa tahun yang lalu kita mencoba melakukan penelitian, kita terbentur pada fasilitas sebenarnya waktu itu. Tapi waktu itu ada model prediktif kita pakai, ada hasilnya. Waktu itu komputernya belum terlalu canggih ya. Sekarang dengan AlphaFold itu lebih cepat lagi. Mungkin kita akan masuk ke machine learning dulu ya. Itu cerita saja. Nanti saya akan ceritakan lebih lanjut tentang hal ini. Mungkin next slide. Kita lihat satu persatu ya, mulai dari machine learning, apa sih yang bisa digunakan di farmasi itu ya. Next slide. Ya. Jadi ini sudah sama-sama tahu lah gitu ya, bahwa machine learning ada beberapa model learning, supervised, unsupervised, reinforced. Nah di sini kalau di farmasi ya digunakan untuk klasifikasi dan prediksi identifikasi molekul yang berpotensi sebagai obat. Nah ini sebagai obat. Mana yang bisa kita pakai untuk obat, mana yang tidak. Nanti kita bisa modelkan, dan sudah banyak dilakukan orang sebetulnya di luar dan penelitiannya. Nah karakteristiknya dari karakteristik apa? Dari karakteristik struktural. Kemudian juga penelitian yang lain mengidentifikasi proses dalam produksi obat. Ini dengan Pak Al-Hadi saya melakukan hal tersebut ya. Ini di sebelah kanan itu ada proses produksi ya. Jadi kalau dalam proses produksi itu satu batch selesai, misalnya pengadukan. Selesai pengadukan, tahap apalagi pencampuran. Setelah pencampuran, masuk proses lainnya. Itu digambarkan dengan 3 kotak yang di atas. Setiap proses diperiksa apakah sudah homogen. Periksa kalau sudah homogen, masuk tahap berikut. Nah, sekarang orang menggunakan proses analytical technology, dan ini artificial intelligence akan memonitor apakah tahap pencampuran ini sudah konvergen, sudah bisa homogen gitu ya. Ketika homogen, batch itu akan pindah ke tahap berikutnya, sehingga tidak perlu ada tahap yang namanya in process control. Di farmasi itu proses kontrol itu mahal karena memerlukan instrumen yang semua industri cukup berat mengadakannya. Nah, dengan PAT, nah ini kita bisa menggunakan continuous manufacturing. Nah ini metode supervised learning dilakukan ya. Nah, kita sudah melakukan S2 kami bersama-sama Pak Al-Hadi, kita melakukan itu. Jadi proses pencampuran itu dimonitor terus sampai satu titik, dia titiknya selesai gitu. Mungkin kalau kita mau bikin di rumah, kalau mau lebaran kita bikin tape ya. Nah kalau pakai ada sensor-sensor pH segala macam, kita bisa tag. Kita akan bisa buat tape yang bagus selalu sama setiap kali bikin. Nah itu silakan Pak Ahli, kita bikin rame-rame nanti Pak. Bikin tape ketan hitam ya. Pasti bagus. Sementara yang uniknya kan kalau kita bikin tape nggak pernah sama gitu kan ya problemnya. Ya, kira-kira itu. Ya, ya, ya. Pakai ketan loh enak Pak. Sebentar lagi lebaran kita puasa. Nah kemudian yang kedua unsupervised learning ya. Mencari pola tanpa pengawasan ya. Itu kita banyak clustering ya. Nah ini untuk analisis data genomik ya. Mengidentifikasi koleksi gen dengan penyakit. Gen mana terkait dengan penyakit mana. Gen mana terkait dengan penyakit mana. Sehingga nanti kita bisa lakukan penelitian lebih lanjut. Sehingga kita bisa identifikasi gen-gen mana yang berpengaruh pada penyakit tertentu ya. Kemudian juga reinforced learning ya. Optimasi proses produksi seperti tadi. Dan pengembangan strategi personal terapi. Ini sudah ke arah klinis ya. Next ya. Next ya. Deep learning ya. Ini dia. Jaringan ada beberapa yang dipakai ya seperti jaringan saraf tiruan untuk analisis citra medis. Nah ini Pak Al-Hadi banyak melakukan itu ya Pak. Analisis citra medis, kemudian prediksi struktur protein dan desain molekul obat. Nah ini yang saya ceritakan tadi. Prediksi struktur protein. Di gambar di bawah itu adalah protein data bank yang mengkoleksi hasil-hasil eksperimental dari eksperimental laboratorium ya untuk menemukan struktur protein. Namun tidak semua struktur protein bisa diketahui dari eksperimental. Jadi hanya orang menemukan struktur dasarnya saja, tapi struktur 3 dimensinya tidak bisa diketahui karena sulit melakukan eksperimental di mana kita harus melakukan kristalisasi protein terlebih dahulu. Itu bottleneck-nya bahwa kita sulit mengkristalkan protein. Nah, sekali kita dapat kristalkan protein itu menjadi harta karun biasanya menjadi oleh satu perusahaan obat. Nah, sekarang bottleneck itu dikejar orang menggunakan simulasi waktu itu. Simulasi dinamika molekuler. Itu orang dulu pernah menggunakan teknik volt at home dulu ya. Mungkin pernah ada yang menggunakan volt at home, menggunakan screensaver-nya komputer-komputer yang tersebar seluruh dunia. Ketika screensaver-nya itu komputer ditinggal, screensaver bekerja, maka dia akan melakukan simulasi dan hasilnya dikirim ke si penelitinya di sana ya. Jadi jutaan komputer seluruh dunia bekerja di situ ya. Nah tapi sekarang dengan AlphaFold ini sekarang jadi lebih mudah. Mereka melakukan pelatihan sistem menggunakan data-data yang sudah dikumpulkan orang ya. Kemudian deep generative model. Nah ini dia. Kita melakukan pembuatan dan evaluasi senyawa kimia baru. Jadi dari hasil penelitian ya, si komputer atau model akan menyarankan senyawa ini untuk penyakit tertentu. Nah ini bisa diuji kemudian. Artinya ketika kita melakukan sintesis itu sudah terarah. Nah ini sekarang orang cepat sekali membuat senyawa-senyawa baru di kimia karena senyawa itu di-generate oleh AI dari yang sebelumnya belum pernah ada dan dia diprediksi aktif terhadap penyakit tertentu. Sehingga trial and error orang melakukan penelitian sintesis itu menjadi berkurang ya. Lanjut. Nah, proses penemuan obat tentunya makan waktu lama nih. Lebih dari belasan tahun ya. Kita mulai dari di sini start dengan 10 ribuan senyawa. Dari 10.000 cuma dapat 1 nanti, ya. Nah, tahapan ini yang drug discovery ini yang dipangkas. Ini dengan sistem apa namanya komputasi. Jadi penelitian-penelitian komputasi umumnya kita sebut dengan penelitian in silico. Itu bisa baik berupa simulasi, prediksi, atau bahkan AI ya. Jadi kita menggunakan istilah in silico eksperimen. Lanjut ya. Jadi dengan revolusi industri 4.0 ya, AI ini sangat berkembang. Ini akan mempercepat proses identifikasi target pengobatan. Seperti tadi kita menggunakan AlphaFold gitu contohnya ya. Kemudian juga akan mempercepat penemuan obat. Lanjut. Ya ini contoh ya. Yang lain adalah natural language processing. Ini di farmasi akan sangat berkembang ya. Kita sudah buat model namanya Falcon Drug ya. Kita ngambil dari Falcon LLM, Large Language Model, sudah kita coba. Sudah bisa diakses dari handphone saya sebagai model ya. Jadi kita cuma bilang pakai bahasa Indonesia apa manfaat obat ini. Tunggu sebentar dia akan cari jawabannya. Kemudian akan jawab dalam bahasa Indonesia juga. Nah, ini modelnya sudah kita buat menggunakan textbook berbagai macam textbook farmasi yang sudah divalidasi oleh tim farmasi klinis kita. Dan ke depan kita akan masukkan juga seperti tadi, undang-undang, peraturan perundang-undangan farmasi, peraturan-peraturan farmasi banyak sekali karena profesi farmasi adalah high regulated. Sangat tergantung pada peraturan ya. Nah, ini kita akan masukkan tambahan di sini nanti. Sehingga kita akan mendapatkan jawaban yang lebih akurat. Cuman terbenturnya adalah satu masalah pelatihan. Pelatihannya kita butuh data yang sangat banyak. Data yang sangat banyak kita butuh resource komputasi yang tinggi pula. Nah itu ya, bottleneck kita. Misalnya masalah yang tadi dibicarakan ya, masalah petaflop tadi ya. Jadi di sini orang sudah bicarakan malah telefarmasi masa depan. Jadi dengan telefarmasi seorang apoteker bisa berdiskusi dengan dokter gitu ya, dengan cepat. Sementara ini sebelum ada model, kalau belum punya model ini, apa yang dilakukan oleh farmasis adalah mengobrak-ngabrik data seluruh database gitu misalnya. Tentu kita berlangganan misalnya Micromedex atau database lain kita cari, kita dapatkan, kita ringkas, baru kita sajikan ke dokter. Dok, ini begini gini. Bahwa obat ini tidak boleh campur dengan ini tidak boleh campur ini. Pada wanita hamil juga tidak bisa diberikan. Nah itu untuk memberikan konsultasi pada dokter. Nah dengan sistem ini tentu akan lebih mudah. Tapi harus ada disclaimer, ini tidak bisa dilakukan tanpa pengawasan dokter karena ini harus dilakukan oleh health professional. Akan berbahaya sekali ketika ini ditanyakan oleh orang awam dan sarannya dieksekusi langsung ya oleh yang bersangkutan, itu sangat tidak disarankan karena harus ada justification expert juga ya. Jadi di sini bisa melakukan informasi tentang efek samping obat, interaksi obat ya, dan layanan telefarmasi. Termasuk juga pencarian penilaian bukti klinis dari jurnal medis itu juga bisa lebih cepat diberikan karena dengan kita memberikan pelatihan dengan menggunakan tambahan-tambahan bukti klinis, jurnal medis, clinical research itu akan lebih mudah memberikan respon ya. Lanjut. Nah, ini robotika dan otomasi. Di Indonesia mungkin belum ada apotek yang seperti itu di rumah sakit. Jadi sistem distribusi di rumah sakit juga sudah menggunakan model-model seperti ini. Jadi obat itu sudah disusun dalam rak-rak yang terstruktur sehingga robot itu bisa mengambil dengan tepat resep yang dikirimkan oleh dokter lewat sistemnya, kemudian dia didistribusi sehingga mengurangi ya kemungkinan obat-obat itu persediaannya terganggu. Jadi problem di apotek atau di rumah sakit adalah sistem persediaan. Jadi sistem persediaan harus akurat, tidak boleh ada obat yang terlalu lama tidak beredar gitu ya. Karena obat itu ada masa simpan atau expire date. Nah ini akan diberikan juga obat-obat yang expire date-nya lebih awal gitu ya, yang diberikan yang lebih lama tidak diambil lebih dulu. Dan tentu pemberian ini juga akan mengefisienkan proses pencarian sehingga lebih cepat pelayanan ya, mempercepat pelayanan. Ya, lanjut. Ya, kemudian adanya model prediksi dan optimisasi ya. Ini bisa untuk memperkirakan efektivitas obat dalam uji klinis berdasarkan data klinis. Kemudian untuk perancangan percobaan obat yang efisien yang mengurangi waktu dan biaya penelitian. Lanjut. Ya, ini contohnya ya, kita ada artikel sini, Artificial Intelligence in Cancer Target Identification in Drug Discovery. Jadi berbagai model di sini machine learning dengan diawali dengan berbagai macam sumber data ya, baik data epigenetik, data genomik, proteomik, dan metabolomik. Tentunya ini semua diolah dengan algoritma-algoritma tertentu sehingga kita mendapatkan target anti kanker ya. Kemudian obat ini apakah bisa senyawa ini apakah bisa menjadi obat ya, drugability. Kemudian drug properties-nya apakah dia toksik, apakah mudah diserap dalam saluran cerna. Nah, itu sekarang orang melakukan eksperimental farmakokinetik itu tidak menggunakan makhluk hidup lagi, sekarang sudah mulai menggunakan data-data hasil artificial intelligence. Jadi kalau kita memiliki suatu senyawa baru, kita bisa langsung bertanya kepada sistem admetox ya, biasanya administrasi pemberian, distribusi ke dalam seluruh tubuh, metabolisme, ekskresi, pembuangan, dan toksikologi. Semua parameter farmakokinetik itu sudah dimodelkan, sudah banyak orang memodelkan dengan model artificial intelligence maupun machine learning itu ya. Sehingga kita bisa memprediksi nasib obat itu dalam tubuh itu seperti apa. Apakah ini bakal menjadi racun atau berfungsi dengan baik gitu ya. Tapi tentunya ini adalah tahapan screening. Semuanya nanti harus dibuktikan di eksperimental juga akhirnya, karena ini menjadi syarat bahwa kita tidak tergantung pada ini, tapi harus ada validasinya. Lanjut. Ya, sistem screening ya dan pemrosesan data ini menggunakan algoritma untuk analisis proses data yang besar, baik dari genomik, proteomik, dan transkriptomik. Juga teknik penggalian data untuk identifikasi kandidat obat yang potensial dari basis data obat maupun senyawa kimia. Ini kami pernah melakukan model seperti ini ya. Pak Al-Hadi ada namanya di situ juga ya Pak. Tahun 2019 kalau nggak salah ya. Jadi kita melakukan screening untuk target di peptidase itu target diabetes ya. Kita mencarinya menggunakan KISAR ya, Quantitative Structure Activity Relationship. Ini berbasis artificial intelligence dan kemudian kita lakukan validasi dengan molecular docking. Nah, ini menjadi dasar nanti model itu bisa dipakai untuk mendesain senyawa-senyawa hipotetis ya. Lanjut ya. Kemudian Nah, ini yang tadi saya katakan, artificial intelligence compound for pharmacokinetic prediction. Ya. Jadi pemodelan prediktif dan simulasi ini juga termasuk penting untuk apa namanya di farmasi ya. Saya pernah melihat juga kemarin beberapa hari yang lalu kebanyakan program-program untuk di sini kan kalau di Fasilkom atau di matematik menggunakan Python ya. Dengan Python itu saya lihat library-nya untuk farmasi sudah banyak sekali termasuk library untuk farmakokinetik. Sehingga ketika kita melakukan eksperimental terhadap suatu parameter-parameter farmakokinetik itu bisa dengan cepat kita gambarkan ya modelnya. Termasuk juga di sini simulasi molekuler ya. Seperti molecular dynamic itu juga dilakukan menggunakan artificial intelligence sekarang. Lanjut. Nah, di sini ya peran komputasi mungkin ini yang kita cita-citakan di sini ya Pak Al-Hadi. Proposal yang diusulkan ini apakah kita akan punya seperti ini karena tanpa alat amunisi dengan amunisi maupun persenjataan yang cukup kita mungkin tidak akan bisa melakukan hal-hal yang besar ya karena kapasitas komputasinya akan sebanding dengan hasil nanti. Jadi untuk melakukan pekerjaan bioinformatik, cheminformatik, kita perlu sumber daya yang cukup ya sehingga kita bisa mengaplikasikan pada berbagai bidang, farmasi, kedokteran, pertanian, konservasi lingkungan, cuaca gitu ya. Sehingga apa yang kita inginkan mungkin kita punya seperti ini satu baris saja sudah bagus ya. Ini mungkin memenuhi ruangan ini gitu ya. Lanjut ya. Nah, tentunya sudah makin banyak ya. Ini beberapa tahun yang lalu saya cek udah banyak perusahaan-perusahaan yang menginvestasikan dananya dalam drug discovery. Tentunya pada saat COVID itu kita melihat berkahnya ya artificial intelligence. Lanjut. Ini adalah salah satu metode dalam penemuan obat cukup panjang metodenya. Metode artificial intelligence dan machine learning biasanya dimulai di tahap-tahap ini ya. Lebih banyak di daerah sini. Sini ya. Jadi termasuk compound repurposing. Di sana juga ada toxicity prediction. Jadi ini target-target pekerjaan yang bisa kita pindahkan ke artificial intelligence dan ini jadi subjek yang menarik bagi banyak researcher sekarang di seluruh dunia. Mungkin kita akan terlibat di mana? Kita tinggal pilih kita mau masuk di mana di sini. Ya, ini luas sekali bidangnya. Lanjut. Nah, ini setelah di breakdown proses drug discovery yang mana yang tadi identifikasi bisa menggunakan prediksi protein-protein interaction. Di sana AI modelnya ya. Misalnya SVM, deep reinforcement itu untuk de novo drug design ini tahapannya ya dari proses drug discovery. Jadi setiap tahapan ada pendekatannya sendiri ya atau mungkin bisa pakai pendekatan lain. Itu malah jadi penemuan yang baru ya. Lanjut. Ini aplikasi yang pernah dibuat orang ya seperti DeepMind, AlphaFold itu untuk target identification ya. PandaOmic, AlphaFold, InClinico. Ya, ini salah satu beberapa contoh aplikasi. Mungkin dari kita akan muncul aplikasi baru bisa saja. Ya, lanjut. Ini lanjutannya ya. Nah, ini target obat-obat yang sudah muncul yang diturunkan dari AI. Perusahaan mana yang aktif melakukan itu yang berinvestasi. Ini obatnya belum dikasih nama ya. Ini perusahaan yang melakukan, ini nama obat, biasanya kalau nama obat eksperimental drug ya, masih kode. Ini targetnya, dan ini penyakitnya, tumor, kanker ya. Kemudian udah fasenya. Kalau udah fase kedua berarti sudah mendekati rilis, biasa sampai fase 3. Kalau ketika fase 3 masuk, itu bisa masuk ke pasar. Lanjut. Nah ini terakhir sudah cukup banyak yang masuk di drug discovery dan clinical trial. Ya, lanjut ya. Ini salah satu model molecular docking menggunakan deep learning. Molecular docking merupakan metode untuk melihat interaksi obat dengan targetnya ya. Sebelumnya mereka melakukan simulasi saja. Jadi simulasi dengan misalnya algoritma genetik ya atau algoritma Monte Carlo itu kan lama. Tapi sekarang dengan deep learning. Ya, lanjut. Ini workflow yang kami kembangkan tadi untuk jurnal kami ya yang DPP 4 menggunakan NIME. Lanjut. Oke, sebagai penutup ya. Jadi AI ini memberikan ruang yang besar untuk inovasi ya dan efisiensi yang sangat besar ditunjang dengan berbagai teknologi yang berkembang sangat cepat. Kemudian manfaat AI dalam penemuan obat menggunakan big data, bioinformatik, informatik, menarik minat industri dan ilmuwan untuk mempercepat proses penemuan obat atau juga melakukan pencarian aktivitas obat baru. Mungkin terakhir ya, lanjut. Ini slide yang menarik. Nah, kalau ini mungkin benar ya. Sebesar ini dikatakan over 10 petaflop. It's right. It's real 10 petaflop. Ya, this K computing from Fujitsu ya kalau nggak salah. Dari Jepang ya. Nah, apa yang bisa dilakukan komputer semacam ini gitu? Coba kita lihat berikutnya. Slide berikutnya, kalau bisa ada suaranya ya. Nah, ini produk dari superkomputer tadi. Suaranya kalau boleh dikeluarkan. Oke. Ini animasi ini bukan produksi kartun ya, tapi ini adalah simulasi yang dilakukan di K-computer
The
ya.
mechanisms of life, simulated through supercomputers. We are inside a cell, in a substance called the cytoplasm, which is packed with a vast number of molecules. It is here in the cytoplasm that complex and diverse reactions involving proteins, metabolites, and other biological molecules of various sizes are orchestrated. New computer programs developed to simulate complex behaviors on the K computer reproduce the movements of tens of millions of water molecules and thousands of large molecules within the cell, making up approximately 30% of the cytoplasm, all at the atomic level. This is a ribosome composed of RNA and proteins, the factory that synthesizes proteins from amino acids. These barrel-shaped proteins are molecular chaperones called GRO-EL that fix misshapen proteins. Giant complexes such as these hardly move at all under the conditions of the simulation. Smaller proteins and small RNA fragments, however, move more actively, despite the crowded environment. and smaller metabolites like ATP move faster still. These simulations show metabolites in the cytoplasm seeming to slide along the surface of proteins and jump between proteins. Future experimental studies are expected to confirm this. Because proteins are surrounded by other proteins in the cell, their structures were thought to be more stable in this environment than in pure water. The simulations, however, show that complex forces acting between different proteins may destabilize them significantly. Protein structure and reactivity are also strongly affected by electrostatic effects of the many metabolites and ions in the cell. Small molecules, such as metabolites and drugs, bind to protein active sites, where they may cause chemical reactions or inhibit normal functioning. There is constant competition between the various proteins and small molecules within the cell, and simulations that take this crowded intracellular environment and its many competitive interactions into account may help predict yet unknown effects, such as potentially dangerous side effects of some drugs. Our understanding of the movement and function of individual molecules within the cell is making huge strides thanks to the use of supercomputers. Identifying the mechanisms underlying many living processes is advancing basic science, but may also lead to the development of new therapeutic drugs.
Ya, artinya kalau kita mau main-main dengan komputasi, tentunya kita harus punya sumber daya komputasi yang cukup. Sebenarnya message-nya itu ya. Jadi kita berharap di UI punya fasilitas yang cukup kuat untuk melakukan simulasi maupun apa namanya AI gitu ya. Saya kira demikian dari saya. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore.
Terima kasih Profesor Hari atas paparannya. So I will switch back to English. So last but not least, we'll have Professor Al-Hadi who will present his presentation on the development of data science in health sector and so Mr. Alexander Krajnov, will leave us a little bit early. So thank you, Mr. Alexander Krajnov, for the presentation. Mari kita kembali ke acara selanjutnya. Sedikit memperkenalkan Profesor Aladi. Profesor Aladi telah memperoleh gelar sarjana di di bidang matematika komputasional. Lalu kemudian beliau juga telah menempuh pendidikan magister di ilmu komputer UI dan memperoleh gelar PhD di bidang bioinformatika di University of Melbourne. Dan hingga saat ini beliau menjabat sebagai Ketua Departemen Matematika di FMIPA UI dan juga menjabat sebagai Ketua DSC. Saat ini juga menjabat sebagai co-chair di Science Technopark UI bidang cluster. Kepada Profesor Hadi, saya persilakan untuk menyampaikan presentasi.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Eh, mohon maaf sebelumnya saya kondisinya masih kurang fit ya, baru kembali dari luar negeri malam. Oke, teman-teman, alhamdulillah alamin, kita ucapkan puji syukur kepada Allah Subhanahu wa taala dan juga salawat salam kepada Nabi Muhammad SAW ya. Ini kesempatan yang bagus kita bisa bertemu dengan partner ya, partner para pihak gitu, dari baik yang dari luar negeri maupun yang internal Universitas Indonesia ya. Jadi acara ini sebenarnya salah satu usaha kita bersama untuk saling berkolaborasi gitu ya. Yang dulu sudah kita kerjakan bersama, baik antara FMIPA khususnya mungkin dari kita Data Science Center dengan Fakultas Farmasi ada Prof. Arianwar dan juga dengan Fakultas Fasilkom ya biasanya dengan Prof. Heru gitu ya. Dan juga dengan tentunya dengan Fakultas Kedokteran ya. Nah, karena UI ini salah satu kekuatan utamanya adalah bidang kesehatan, life science ya. Makanya kita di FMIPA ya khususnya di Departemen Matematik kita terinspirasi gitu. Bagaimana matematika ini nanti bisa berperan di real life problem gitu ya. Makanya kita melakukan kolaborasi gitu. Dan salah satu bidang yang paling pas untuk berkolaborasi adalah bidang data science. Nah, ini karena data science itu tidak bisa bekerja sama satu pihak saja. Jadi kita harus bekerja dengan berbagai pihak untuk merumuskan masalah, mencari solusi dan nanti bisa memberi impact kepada masyarakat gitu ya. Nah, untuk yang terakhir ini saya nggak lama-lama, mungkin nanti men-summarize apa yang sudah dibicarakan oleh pembicara-pembicara sebelumnya. Intinya adalah bagaimana perkembangan AI ini bermula dari matematik gitu ya, matematik, statistik, dan berlanjut dengan ilmu komputer, berlanjut dengan ilmu-ilmu bidang terapannya. Dan ini yang akhirnya menjadikan sekarang AI ini menjadi salah satu apa ya harapan kita ke depan gitu ya, untuk bisa bekerja lebih cepat, lebih efisien, dan bisa memberi impact yang cepat dan dampak yang besar kepada masyarakat. Tentunya kalau AI ini diaplikasikan secara inkonsisten gitu ya. Ya, secara konsisten kita udah training modelnya dengan akurasi di atas 90%, 95%, 99% gitu. Setelah dijalankan di lapangan jangan diacak-acak lagi datanya gitu ya. Jadi harusnya AI ini bisa menjadi solusi gitu. Setelah selesai ya serahkan ke AI untuk menyelesaikannya. Jangan ada kasus AI-nya udah dipakai di lapangan, datanya dirubah lagi di belakang. Itu kan akhirnya menghancurkan kepercayaan masyarakat pada AI gitu ya. Nah itu yang menjadi concern kita saat ini, yang cukup memprihatinkan gitu. Kalau terjadi ya mungkin pahamlah maksud saya ya. Oke, nah di sini saya akan membahas sekilas bagaimana perkembangan dari AI itu ya dari data science sekarang sudah menjadi generative AI ya. Dan generative AI ini salah satu yang akan menjadi terobosan-terobosan di masa depan ya. Balik dulu ya slide-nya. jangan lompat-lompat. Nah, ini kerjasama yang sudah kita lakukan dengan banyak pihak, ya, baik di dalam dan di luar negeri, ya, baik dengan bidang life science ataupun bidang-bidang lain, ya, misalnya bidang yang terkait dengan pertanian, gitu, ya, ataupun dengan bidang kesehatan, dengan bidang asuransi, kita life science. Dan alhamdulillah ini kalau diperbesar itu ada Celeris itu, ya. Itu minggu kemarin kita udah launching Celeris, salah satu platform underwriting, ya, di bidang insuran yang berbasis AI. Dan kita sudah soft launching minggu kemarin dan sudah beritanya sudah muncul di koran-koran nasional, ya. Dan ini salah satu terobosan terbesar sekarang di bidang insuran, ya. Kita melakukan proses underwriting itu sudah pakai AI. Jadi, dan ini yang salah satu yang dihasilkan oleh teman-teman kalian yang kemarin S2 di matematik, ya, di bawah bimbingan kita. Ini secara garis besar, ya, lanjut terus, lanjut. Nah, ini secara garis besar data science, di mana ada 3 pilar, ya. 3 pilar utama itu adalah secara teorinya ada matematik, statistik, secara implementasinya nanti di dalam aplikasi pakai computer science, dan secara domain knowledge-nya ya pihak terkait, ya, yang akan menjadi kolaborator kita, ya, untuk kita nanti mendapatkan problem yang mungkin kita bisa selesaikan, gitu. Nah, salah satunya mungkin dengan farmasi kita problemnya adalah misalnya drug discovery dan sebagainya yang sudah selama ini berjalan dan sekarang terus berjalan. Jadi kesempatan ini sekarang juga membuka wawasan, mungkin di sini ada beberapa mahasiswa saya yang ikut, ya, membuka wawasan, banyak peluang nanti ke depan yang bisa kita lakukan kolaborasi. Apalagi sekarang melalui UI Advisory kita menjalin kerjasama lebih intens dengan Fasilkom, ya, dengan tentunya dengan teman-teman di Fasilkom yang mungkin lebih expert di bidang computingnya, ya, computer science dan sistem, ya, IT-nya. Mungkin lanjut. Nah, ini beberapa peran penting mungkin dari sisi matematik, gitu, ya. Bagaimana mata kuliah dasar matematik itu yang menjadi fondasi awal untuk membangun data science, machine learning dan AI ke depannya. Kemudian dilanjut dengan bidang computer science, yang ini memang mereka expert di bidang bagaimana mendevelop infrastruktur yang bisa terkait dengan pengolahan datanya sampai nanti menyajikan aplikasinya di lapangan, ya. Sehingga terbentuklah sistem yang kita namakan artificial intelligence. Jadi kalau kita bicara artificial intelligence itu sebenarnya kayak mobil, gitu, ya. Ada engine-nya, di dalamnya ada data science dengan machine learning dan sebagainya, dengan model-model pembelajarannya, lalu di-develop menjadi suatu sistem yang komplit, jadi suatu mobil, yang itulah disebut dengan artificial intelligence. Cuma kadang-kadang kita sering kelupaan data science-nya, gitu. Jadi makanya saya tetap emphasize di sini peran dari data science itu. Karena kalau data science-nya nggak kuat, inovasinya nanti juga akan kelabakan, gitu, ya. Ini yang harus kita perkuat. Makanya di UI itu sekarang ada sudah ada di Direktorat Sains Teknopark itu yang membidangi bidang data science AI ini, di mana di Direktorat Sains Teknopark itu kita kolaborasi sebagai core-nya itu adalah Fasilkom dan MIPA, gitu, di bidang data science dan AI, gitu, ya. Jadi saling memperkuat itu. Nanti berkolaborasi dengan semua bidang lain. Kenapa UI ini menjadi bagus untuk pengembangan AI? Karena kita banyak sekali fakultas yang terlibat, ya. Seperti yang tadi ada fakultas hukum juga ada, kan. Dan ini ke depan kita akan berkolaborasi juga mungkin pengembangan untuk mental illness, ya, dengan psikologi dan sebagainya. Di samping yang sudah berjalan dengan kedokteran, dengan ekonomi dan sebagainya. Termasuk juga dengan FISIP, ya, yang banyak berhubungan dengan data-data sosial media dan sebagainya. Lanjut. Lanjut. Nah, ini secara grand design bagaimana proses life science dari data science itu, ya. Di mana di dalam proses ini bertemulah para pihak tersebut, ya. Baik yang domain expertise-nya, bagaimana kita membuat business understanding-nya, ya, dengan domain expertise. Sampai nanti bagaimana datanya kita olah, kita apa istilahnya kita lakukan feature engineering dan sebagainya sehingga data itu bisa nanti dijadikan bahan untuk membuat apa namanya data set ya untuk training modelnya yang akan kita kembangkan untuk menyelesaikan masalah yang ada di dalam dunia realnya itu. Sebenarnya intinya dalam yang diperlukan ya oleh dunia industri itu atau dunia nyata itu ada 3 aja sebenarnya. Bagaimana kita bisa menyelesaikan masalah kesulitan mereka itu ya. Kalau di dalam kesehatan makanya masalah kesakitan mereka lah gitu ya. Kemudian bagaimana kita bisa menyelesaikan secara efisien gitu, secara cepat dan murah gitu. Jadi kalau ketiga ini dapat pasti laku gitu. Masalahnya bisa diselesaikan dengan cepat dan murah. Contohnya tadi yang kita kembangkan Celeris tadi ya. Di situ bagaimana kita melakukan apa namanya endorsement terhadap calon dari nasabah. Nah, biasanya kan kita harus melakukan banyak proses ya. Dari apa data dokumen, data tes lab, mungkin medical check up dan macam-macam. Dan itu prosesnya lama dan mahal. Nah, kalau kita bisa terobos itu dengan AI, kemarin kita mengembangkan terobosannya apa? Cukup mengambil video dari wajah dia dalam beberapa detik gitu, dan kita bisa menganalisa vital sign yang ada di orang tersebut sehingga bisa nanti dipakai untuk industri asuransi. Lanjut. Nah, ini kalau perspektif dari dari sisi bagaimana learning modelnya, kita bisa kalau tuliskan data science sebagai induknya ya. Lalu di dalam itu ada AI, di dalam AI itu ada machine learning dan ada deep learning. Nah, sekarang di dalam deep learning itu ada generative AI. Jadi secara model pembelajarannya itu lebih fokus di bidang data science, tapi bagaimana implementasi di lapangan sehingga menghasilkan suatu terobosan kecerdasan buatan itu nanti kita berkolaborasi dengan anak-anak dari computer science ya. Lanjut. Nah, kenapa kita butuh data science ini ya banyak kasus yang karena sekarang kita sudah berada di dalam zaman big data ya. Jadi dengan segala macam data, segala macam apa namanya parameter, segala macam pihak yang terlibat sehingga untuk memutuskan itu banyak sekali bias gitu ya. Kalau kita menggunakan model-model statistika yang standar ya tradisional yang menggunakan hipotesis H1, H0 dan sebagainya itu akan sulit sekali dan butuh waktu lama. Nah, salah satu terobosan itu adalah dengan menggunakan data science. Nah, data science itu bisa mengimprove kecepatan untuk melakukan decision making tersebut. Kemudian bisa nanti banyak dipakai nanti untuk risk mitigation kayak tadi, analisa risiko calon nasabah atau fraud detection ya. Nah, fraud detection yang mungkin kalau kita menggunakan pendekatan human itu errornya besar sekali. Kemudian trend analisis ya kayak kemarin untuk presidensial kemarin ada mahasiswa kami melakukan penelitian ini ya sentimen analisis. Sebenarnya hasilnya sudah kami publikasikan ya. Oke, continuous improvement ya. Di sinilah kebutuhan data science untuk berlanjut terus penguatan dari peningkatan dari kinerja organisasi itu. Ya. Nah, seperti yang disampaikan sebelumnya, histori dari AI itu ya mulai dari yang sifatnya supervised gitu ya, unsupervised, kemudian ada yang sifatnya recurrent gitu ya, reinforcement learning dan sebagainya. Sekarang masuk ke zamannya deep learning dan generative AI ya. Dan salah satu pilar utamanya itu adalah generative AI ini kita bisa mempredik sesuatu yang apa ya, yang lebih nyata, yang kelihatan nyata untuk ke depan gitu ya, menggunakan data-data yang sebelumnya yang mungkin data tersebut juga bisa kita generate juga gitu menggunakan AI. Jadi AI for AI gitu ya, dari AI menghasilkan AI baru gitu ya. Yang kalau kita gunakan untuk hal-hal yang positif itu akan sangat membantu sekali gitu. Jadi bisa meningkatkan kreativitas, meningkatkan inovasi gitu ya. Kemudian automation system bisa berjalan dan bisa juga masuk dalam bidang art dan musik. Jadi bisa yang tadinya mungkin lebih banyak kayak sifatnya mechanical AI gitu ya, yang lebih kayak produksi sebagainya, sekarang lebih luas gitu, mencakup hampir ke semua aspek manusia. Nah, di sini challenging AI ke depan itu ya. Dan salah satu temuan yang paling menarik adalah ya tadi seperti bahas sebelumnya ada atau encoder yang menjadi basis dari generative AI dan juga nanti algoritma transformer ya. Dan ini yang menjadi revolusi di bidang AI. Di mana ada proses encoder supaya data yang tadi kompleks bisa kita bikin lebih simpel, bisa kita pelajari lebih cepat, lalu kita melakukan proses decoding kembali untuk menyelesaikan solusi di masalah yang kita mau selesaikan. Nah, ini kami sudah mengembangkan generative AI ini di data science center kemarin di bidang klinikal ya. Bagaimana kita memproduce data sintetik gitu ya di bidang kesehatan. Misalnya di bidang kemarin penelitian kita bidang jantung ya, EKG. Karena kesulitan untuk mendapatkan data dari medical ini kita bisa menggunakan generative AI. Dan ini untuk penyakit-penyakit kronis itu banyak sekali challenging-nya di sini karena kalau kita mau mendapatkan data real itu akan sulit sekali. Nah, ini salah satu bisa kita gunakan terobosan dengan ini ya, generative AI. Dan ini banyak sekali bidang yang berkembang ya. Nah, termasuk nih algoritma-algoritmanya juga terus berkembang. Seperti ini kita tambahkan variational auto encoder dan sebagainya yang di situ ada penguatan dari sisi probability density function-nya. Jadi data itu kita pelajari supaya nanti kita bisa mengenerate data baru dengan PDF yang mirip gitu ya. Kalau PDF-nya mirip, itu datanya akan makin mendekati data yang sebenarnya. Dan ini banyak sekali dipakai di dunia kedokteran ya. Sampai berkembang sekarang kalau yang autoencoder itu lebih banyak ke bidang image. Nah, transformer ini banyak kemarin digunakan untuk teks ya. Bagaimana kita membuat generative AI based on text ya. Sehingga muncullah chat GPT dan sebagainya. Nah, kalau kita combine autoencoder dengan transformer ini, maka banyak sekarang aplikasi-aplikasinya lebih general ya menjadi large language model. Dan datanya nggak hanya teks gitu. Kayak tadi Prof. Andri udah ngumpulin bisa dalam bentuk audio ya Pak ya. Jadi datanya sudah multimodal data. Nah, ini yang menjadi challenging kita ke depan. Kami di Data Science Center bekerja sama dengan banyak pihak ini sekarang mengembangkan large language model, terutama di bidang kesehatan ya. Salah satunya dengan Kalbe. Bagaimana kita coba mengkombin antara data bidang kedokteran dengan data bidang farmasi gitu. Untuk menjawab challenging di bidang penyakit tertentu ya. Yang mungkin kalau kita mengandalkan tenaga manusia akan sangat sulit gitu ya. Karena untuk mendidik seorang dokter spesialis itu butuh waktu bisa 30 tahun gitu ya, yang benar expert gitu. Nah, dengan penggunaan ini mungkin akan sangat membantu ke depan. Nah, ini contoh yang kita kembangkan dengan Kalbe ya, Kalbe digital, penerapan LLM untuk bidang kesehatan. Nah, ini banyak sekali field yang bisa kita kembangkan di bidang, coba lanjut ya. Lanjut. Ya, lanjut. Ini chat GPT, lanjut. Ya, lanjut. Ya, lanjut. Lanjut. Nah, ini kita bisa kembangkan banyak hal ini. Seperti yang saya sampaikan tadi, ada dari sisi musiknya, ada dari sisi biotek, termasuk juga untuk coding ya. Coding sekarang kita bisa belajar lebih cepat gitu ya, dengan adanya generative AI. Pembuatan coding, pembuatan software, dan sebagainya. Marketing, drug discovery tentunya ya, yang menjadi concern kita saat ini. Lanjut. Nah, ini coding. Sekarang untuk terutama untuk mahasiswa S2 ya, yang kalau di kita itu matematik ada S2 data science, dan memang banyak inputnya dari luar ya, dari daerah, dan ini kita bisa mempercepat mereka untuk bisa menguasai program itu menggunakan generative AI. Jadi misalnya pakai belajarnya dari ChatGPT dan sebagainya, dan ini sangat membantu sekali gitu. Bisa mereka belajar lebih cepat. Masuk juga untuk mendrive aplikasi berbasis web dan sebagainya ya. Lanjut. Bisnis marketing. Ini banyak sekarang untuk marketing itu sudah pakai generative AI ya. Bisa lebih cepat tuh generate konten-konten dan sebagainya. Sehingga mempermudah. Termasuk dalam musik ya. Lanjut terus ya. Lanjut. Biotek ya. Ini sudah banyak sekali sekarang open source yang juga bergerak di bidang biotek ini ya, yang bisa kita nanti optimalkan gitu ya. Kita bisa manfaatkan yang sudah ada untuk menyelesaikan kasus-kasus yang kita bisa kerjakan di sini. Masuk drug discovery tadi ya, Prof. Ari sudah nyampaikan. Dan ini banyak juga kita explore lebih dalam ini di di proyek-proyek mahasiswa S2 kita, juga S1. Nanti ini kolaborasi terus berlanjut dengan farmasi ya, dengan Prof. Ari dan teman-teman lain. Protein modeling seperti sampaikan Prof. Ari tadi. Nah, ini beberapa challenging. Ini challengingnya memang pertama ya data ya. Data science itu nggak akan jalan kalau nggak ada datanya ya. Jadi kalau datanya nggak ada ya nggak bisa gitu. Jadi memang pertama data integration, kualitas data, kemudian privacy and security. Nah ini selalu jadi ininya trade off-nya ini ya. Kalau ingin security-nya bagus, nanti kita susah ngakses datanya. Kalau mau gampang, sepertinya ini. Jadi ethical concern, nah ini juga social acceptance. Nah ini kalau AI ini kita bisa terapkan ya secara prudent gitu, secara benar, mungkin social acceptance-nya akan bagus ya. Tapi kalau ada sesuatu yang dilakukan di belakangnya itu ini sangat berbahaya ya. Orang nanti akan kehilangan kepercayaan kepada AI ini. Dan ini kami sangat concern seperti itu ya. Sayang sekali gitu. Sudah dibangun sistem yang bagus gitu. Ternyata ada sesuatu di belakangnya yang mungkin membuat sistem itu akhirnya tidak berfungsi dengan benar ya. Challenge berikutnya legal issue, model explainability. Nah ini karena kebanyakan AI itu kan seperti black box ya. Jadi orang banyak mempertanyakan gimana nih penjelasannya. Dan ini salah satu challenging yang bisa kita jawab mungkin dari sisi data science. Seperti di Celeris itu kami akhirnya bisa menjelaskan itu model-model yang kita kembangkan itu secara pendekatan data science, dan itu akhirnya bisa diterima sama industri. Jadi kalau kita bisa membuat model itu bisa dijelaskan dengan baik, nah ini mungkin social acceptance-nya akan lebih bagus ya. Lanjut. Opportunity. Nah, opportunity itu pertama banyak sekali AI itu yang memang dikembangkan untuk mechanical intelligence ya. Proses-proses yang tadinya berjalan berulang-ulang gitu. Nah, ini secara mekanik, nah ini sudah banyak berjalan ya, sudah menggunakan di replace dengan AI sekarang. Ini sudah berjalan banyak. Selanjutnya analytical intelligence. Nah, ini banyak yang sedang berkembang sekarang ya. Terutama di bidang kesehatan gitu kan, kedokteran, bidang pertanian dan sebagainya kayak tadi ya. Bidang keuangan, dan ini lagi berkembang pesat ya. Dan ini menjadi challenging kita ini yang bisa kita selesaikan di dunia. Selanjutnya, nah ini akan berkembang lebih dalam lagi nih ke depan, intuitif. Lanjut. Nah, intuitif intelligence ini seperti yang tadi yang terkait dengan hukum, terkait dengan macam-macam tadi ya, terkait dengan hal-hal yang sifatnya lebih kompleks gitu. Dan ini kalau AI bisa masuk, ini akan sangat membantu ya di dalam mempermudah kehidupan di society kita berikutnya. Dan yang terakhir ini yang lebih dalam lagi ya, empathic intelligence, dan ini melibatkan emosional ya. Dan ini sedang menjadi challenging benar nih, karena misalnya di psikologi bagaimana menganalisa mental illness gitu ya. Kemudian kami kemarin diundang sama Kementerian Pertahanan. Bagaimana ini masalah besar, salah satunya untuk rekrutmen ya, rekrutmen TNI itu masalah LGBT. Nah, ini kan agak sulit nih mendeteksinya. Apakah bisa pakai AI gitu atau gimana? Nah, ini challenging yang mungkin ke depannya. Terakhir mungkin saya akan sampaikan di sini. Ini berita bagusnya ya. Ternyata dengan kemampuan generative AI sekarang ini, kita bisa lihat ya, itu adalah grafik menunjukkan bagaimana di sisi atas itu test loss ya. Test loss itu bagaimana akurasinya ya. Kalau datanya kita makin besar, makin bagus gitu ya, makin ini kita lihat itu. Test loss-nya makin mendekati nol ya, makin ke bawah ke bawah. Jadi memang AI ini ke depan akan membuat yang tadinya sepertinya masih agak jauh dari kenyataan akan mendekati kenyataan. Jadi apalagi dengan generative AI itu ya, akan mendekati test loss-nya mendekati nol gitu. Cuma ya tadi concern kita tadi Prof Ari ya, kita belum punya computing power yang cukup untuk data sebesar itu ya. Coba kita lihat parameternya 10 pangkat 9. Gede banget parameternya kan. Data size-nya 10 pangkat 9. Nah, kita butuh computing power-nya yang besar gitu. Dan alhamdulillah ya, lanjut. Kemarin kita initiate untuk mengajukan proposal untuk pembangunan high performance computing facility kita di UI gitu. Untuk yang tahap awal kita dapat di Direktorat Sains Teknopar itu kita akan dapat 3 mesin superkomputer gitu yang cukup bagus ya untuk awal. Nanti berikutnya kita akan dapat lagi yang bantuan langsung dari pemerintah pusat, insya Allah ya. Itu kita lumayan besar anggarannya. Cuma kemarin kita baru mungkin dapat tahun 2025 prioritasnya itu. Mudah-mudahan ini kalau kita berhasil akan menjadikan Universitas Indonesia salah satu center untuk pengembangan data science AI ke depan di Indonesia ya, khususnya untuk level universitas ya seluruh Indonesia. Karena lumayan besar itu yang kita ajukan gitu. Mungkin itu saja sebagai wrap up ya, sebagai pembungkus lah sesi kita hari ini. Mudah-mudahan ini bisa memberi wawasan kepada teman-teman semua dan juga dengan adanya kegiatan ini mungkin komunikasi kita antar berbagai bidang makin lancar ya, sehingga kita bisa mengerjakan proyek-proyek yang lebih bermanfaat gitu ke depan. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih Prof. Al atas paparannya. Sebagai penutup, kembali lagi, data science, kecerdasan buatan, machine learning, tidak lain dan tidak bukan hanyalah kolaborasi. Berawal dari ide dari matematika, dikembangkan infrastrukturnya melalui fasilkom, ilmu komputer, dan diterapkan di berbagai bidang seperti kesehatan, psikologi, dan sebagainya. Dan itu akan selalu berulang. Dan semoga acara seminar ini memicu teman-teman untuk lebih mendalami AI, mendalami data science, ya, sehingga kedepannya kita bisa lebih terlibat banyak dalam bidang ini. Saya dan segenap panitia sebelumnya ingin mengucapkan permohonan maaf apabila ada perkataan dan perbuatan yang mungkin kurang berkesan bagi para audiens. Dan izinkan saya, Erlan Rahmat Ramadan, selaku pemandu acara ini untuk mengundurkan diri. Salam. Wassalamualaikum warahmatullahi wabarakatuh. Yuk. Bisa maju, bisa maju. Kita foto bareng sama Prof. Ari dan Prof. Al.
Tamira ini ketuanya Ristek Fasilkom di General Data. Oh iya. Baru datang dari kami waktu kapan kita memang sudah. Mbak Mira naik Mbak. Ini mbaknya, cewek, berhenti ya.
Ladies first.